Так, начинается настройка стрима вживую. Внимание, Вова, мы в эфире. Слышишь?
Да.
Ждем коллег, когда присоединятся. Вова, у тебя не на весь экран презентация.
Но она на весь экран. Я F11 нажал.
Нет, Вова, у тебя не на весь экран презентации. Все, еще нет.
Сейчас?
Останови расшаривание экрана. Попробуй снова. Да, только это сейчас не перерыв.
Ну, а там нету просто чего-то.
Хорошо. Давай поставим пока заставку. Начинаем мы через 5 минут. Получается в 50.
Good morning.
Hello, are you hear me?
Yes.
Perfect. Our conference start at 10 a.m. I want to check presenter. First presentation from Alexander Serabalov.
Yes, yes.
Second from Indira Uvaleva. Are you here? Okay. Third from Mao Chan Nugeev. Oh, sorry, Mao Chan Nguyen. I'm sorry, I don't know how to spell it. And second, yes.
I'm Tomchuk Alena, and if this record has my name, I will.
Okay, I see you as okay. And the last, Emilia Demirova or Fedor Durnev. Okay, dear friends, please answer me. Could you show presentation from your PC, or you prefer to speak and I will change slides?
We had the third record, and the reporter will be Fedor. Do you see that?
I'm sorry. We have two options. I ask about way of present your presentation. We have two choices. First, we have two options. First options, you can share your screen with your presentation, and you will present your presentation from your PC, or I can share my screen with your presentation, and you can spell only voice, and I will change slides when you say to me.
I don't know, maybe it will be comfortable that we will list, but I can't set for everybody. That's why I need to ask somebody else too. Maybe you can list, I think it doesn't matter.
Alexander, are you hear me?
Yes, yes. Option one.
Okay. Alexander, are you, do you have a problem with join to our meeting?
No. It is simple.
Okay, so thank you. Thank you for check. Dear Al, we stay meeting online during the break. I'm sorry, it's improper improper save screen because currently it's not break. But on breaks we can stay microphones opened and we can discuss about your presentation.
Hello, good morning, everyone.
Hello.
My name is Fyodor Zuni, so I'm going to tell, I haven't, I guess, about an algorithm about the onset on epileptic seizure, so I'm going to tell my part, I guess. So in the plan, it's about like at 10:30. So that's me. I'm here.
You speak about architectural and algorithmic model for intelligent clinical decision support system.
Problem analysis. That's from the word problem analysis of the.
Oh, problem analysis. Sorry. Okay, we have three presenter here, but we don't have presenter for second speech. Excuse me. Could you present your results before? I asked about this for Alyona Tomchuk and Fedor Durnev.
Oh, yes.
Thank you. Okay, I share my screen with our schedule. I will glad to see your presentations. Diral, I'm sorry, we start after 2 minutes because we are waiting other presenter. If they not join, we pass second presentation.
Will we list presentation by ourselves or you will do it?
Diral, please say me what type of presentation is suitable for you. You can show from your screen, or you can or I can show from my screen, and you will speech.
Maybe you can show if you can.
Okay, I can show. So sorry, who is first presenter?
Alexander.
Alexander, are you hear me?
Yes, yes.
Do you share screen or?
You sure? You're sure?
Okay, you. Please, second presenter. I'm not here. Third presentation. I share or you share screen?
I think you share, or
okay.
Can I change a little my presentation and send you, or I will with the...
I suppose it's not impossible now because we have small, not enough time.
Okay, it's not a problem.
Okay, and third presenter, could you answer me, please?
You share.
So sorry, so first.
So you share. It's okay.
Okay, let's start. I stop sharing my screen, and I was wait for first presenter for start presentation. Please be glad to hear your speech. We were glad to hear your speech.
You show me the presentation.
Okay.
Please.
Sorry. Okay.
Okay.
Let's start, please.
Good morning. My name is Alexander Serova. I am postgraduate student of the chair of Automated System of Information Processing and Management, Home State Technical University. The subject of my research article is intelligent processing of medical information for application in the expert system. Our present medical expert system, based on modern information technology, find broader application as in medical studies as in a real critical practice. Medical organization develop new approach to therapeutic procedures, purpose and support. Collect and generate data required fast.
Excuse me, could they change slides or not?
Okay, of course. The medical community is not to pay much attention to issues of patients' compliance rate to medical support as it influences the treatment quality and result. Moreover, it is relevant as developing predictive models of diseases as working out ways of influencing the patient.
Excuse me, Alexander. I'm on second slide of your presentation. Are you here? Are you here? The what's happened in Zoom? Do you see? Could you see what happened? What happened in Zoom, please? Not in the stream.
what the medical community is not to pay much attention attribute to the applied therapy. Also, it is important to develop approach to estimate the effectiveness and duration of medical interference. The article examines as approach to processing as and analyze data about patients' compliance rate to therapeutic interference through application of fuzzy logic mathematical tools, whose intellectual technology or knowledge processing and fusion are usually applied when there are uncertainties and incompleteness of knowledge about object description. Slide 3. Numerous clinical research in the therapy of patients with chronic diseases prove that one of important issues is the patient's attitude to the ongoing therapy, value of positive and negative effects, and finally to treatment results. Questioning is the most preferred method for assessing adherence to therapy if we take into account the ratio of laboratory effectiveness. Slide 4. In the questionnaire offered to the patient, answers to questions or evaluated in points. Processing the result is carried out in 3 stages. At the first stage, first order indicates or calculates which are called importance for the patient of the problems associated with the disease and patient's readiness for treatment. Each index represents the sum of the points obtained when answering the relevant question regarding medical therapy, medical support, and updating of the way of life. As the second stage, synthetic index of the expert treatment effectiveness or calculated by summing the inverse values of the first order indicators with white corresponding to the indicator importance. The final result obtained in the third stage is the integrated expert treatment effectiveness index, which is calculated by summing the expert efficacy indexes with empirically specified white coefficient. By its value, it is determined which group the patient belongs to: high, satisfactory, or unsatisfactory expert treatment effectiveness. Slide 5. Following the method, one can estimate compliance to therapeutic interference in a quantitativity equivalent by 3 criteria: expert effectiveness of updating of way of life, expert effectiveness of medical therapy, expert effectiveness of medical support. Slide 6. The study subject is in the category of patients who have the most similar type of therapy compliance in the aggregate by 3 criteria of the expert effectiveness. Slide 7. To solve the set task of identifying groups of patients having the most similar properties of compliance rate and considering all 3 criteria, an algorithm of fuzzy C average is used. The peculiarity of the fuzzy C average algorithm is that data are represented as fuzzy set, and each element can belong to several clusters with a certain degree of membership. Every ith line expresses the degree of belonging of the ith patients to the cluster IG formed according to the degree of competence for each of the criteria. So L is a number of patients and C is a number of clusters. Competence rate is nu is G from 0 to 1. Slide 8. First step. The number of clusters is determined on considers C equals 3 interprets initial cluster as group according to their competence and weighting coefficient on the elements on considers M equals 2 when the parameter is used for calculating cluster center. Also, an algorithm terminate condition is considered starting from the specified occurrence of the solution. Second step, the fuzzy Persian matrix M based on the following considerate is generated. All objects are to be distributed for each cluster according to the equation. Moreover, no cluster is empty set or contains of the elements. Next slide. First step, cluster centers are calculated with an equation where MET belongs to MET is if objects of the G cluster. Fourth step, distance between objects from the matrix M and cluster center is calculated with respect to the data under study. Each row of the matrix contains the complex indices of the individual patients. Each column of the matrix contains value of the indices I, E, U, W, L, IMMT, IMS, respectively. When determined the distance between objects, the Euclidean distance is used and is geometric distance. Slide 10. Five step, fuzzy partition matrix elements of patients or calculate a formula. Sixth step, it is stop criterion module M minus M less E. Also return on third step. Next slide. The initial data are formed on the basis of Professor Nikolaev's questionnaire. It helps to estimate such a qualitative parameter as complex in quantitative equivalent. This study examined the criteria for the expected effectiveness of medical support, updating of way of life and medical therapy. The study included 160 patients with cardiovascular disease from 40 to 85 years of age. The data for the study group of patients are particularly present in the table. Next slide. The table has 4 columns: patient index I, E, U, W, L, I, M, T, IMS. The effectiveness of the treatment was measured quantitatively. At the same time, its value in the range from 1 to 2 points indicate good effectiveness, from 2 to 4 points indicate satisfactory effectiveness, and 4 points or more indicate unsatisfactory effectiveness of interventions. For class and next slide. For cluster analysis, individual characteristics of patient complaint rate to be identified and quantified. Were used for grouping by the expected effectiveness of treatment. This slide shows the result of clustering on each degree of the expert compliance to therapy, or indicate X is high, O is satisfactory, plus is unsatisfactory. Simple O means cluster is center. This approach demonstrates possibility of identifying a group of patients with similar criteria to classify it without preliminary information, and later to develop function of membership and do it then draft a conclusion about new patients' complaints. Next slide. Based on cluster analysis and identified cluster centers, there are developed function of terms belonging to patients with varying degrees of compliance to treatment. This slide shows the result of membership function by expert effectiveness criteria. Red color indicates high effectiveness criteria, green color indicates satisfactory effectiveness criteria, blue indicates unsatisfactory effectiveness criteria. Next slide. Every fuzzy cluster can be mapped to a fuzzy rule and is to be performed in future for development and expert system. Accurately, the degree of competence of every input variable will be considered when forming every fuzzy rule. Membership function are obtained by project the corresponding cluster belonging degrees. Projection of matrix rows of fuzzy patients M on the axis of experiment expected efficiency index. Next slide. Analyzing the result of clustering the following groups of data to apply additional analysis are or to be considered and as a result to determine recommended setting for prescribing medical supports. Disputable objects that have an equal degree of membership to several clusters. Emission, that is object with extremely low competence to all available cluster. Objects directly belonging to the cluster, but with a pronounced predominance of one or two indicators. For example, a patient has high competence to the drug therapy, but at the same time, he has extremely low competence to modify lifestyle and medical support. Based on the obtained results, it is an experiment to formulate and to solve the task of modernizing the realized method of fuzzy clustering that can reflect all the specifics of the data under study, as well as to consider this specificity with subsequent extraction of fuzzy rules. Next slide. As a result of the studied three groups of patients were formed according to the complex rate. Information on the border sets of each criteria is obtained. The membership function for each indicator or developed for future use in the expert system. The use of the proposed method of proportion processing medical information in the aggregate with techniques designed to be used in clinical practice, develop intelligent system for cardiac patients. Such a consultant expert system of support will significantly improve the efficiency of the cardiologist when prescribing drug therapy. Thank you for attention.
Thank you very much. We have some time for one or two questions. Please. Okay. We have no questions. Okay, I ask one question. What does it mean? What is expected efficiency index here, and how you calculate it?
Calculate on summa criteria first parameters.
Okay, thank you very much. Thank you for your presentation. And I'm asking for the second presenter. Are you here? Second presenter, are you here? The second presentation is Indira Ivalyeva, and I Can't see her. Okay. If some people have troubles with joining our conference, we bring missed presentation to the end of the day, because currently for me it's obvious that we have a lot of problem with technical part. And the third presentation, it's presentation for of Alena Tomchuk. Are you here? Could I hear you?
Yes, I'm here.
Could you share your screen, or you prefer speech and show slide from my PC?
I think the second variant is great.
Okay. Okay, let's start, please.
Hello, my name is Alena Tomchuk, and I'm a student of St. Petersburg Electrotechnical University. And today, I, on behalf of our research group, would like to present you a report on the topic: a smart mobile system for monitoring and assessing sportsman physiological results during training. The next slide, please. Training of a professional sportsman in sport of high achievements always needs an optimal plan and appropriate training program. That's why in sport medicine, the analysis of biomedical indicators that characterize the organism's physiological results allows to assess the potential of an athlete and plan training process and predict and improve results of sport activities. Hence, the development of a smart mobile system is relevant. Next one, please. The purpose of our work is to form a complex of biomedical indicators, is to develop methods for processing signals, and to develop a structure of smart mobile system that allows to obtain and process biomedical signals. And to achieve this purpose, we need to solve the following tasks: to form complex of parameters, to develop a method of processing, and to develop a structure of smart mobile system. The next one, please. Let's talk about the medical parameters. To assess the physiological result, it's necessary to form a complex of the medical parameters that characterize the activity of different systems of sportsman organism. Previously proposed complexes take into account only a few physiological parameters, but this is not enough for an accurate assessment. That's why we propose such complex of these indicators, which include heart rate, blood pressure, breathing rate, blood saturation, and heart variability, which represented by the range of intervals and the variance of intervals. And based on the analysis of obtained parameters at different levels of physical activity, we can form a conclusion about physical potential of the sportsman and his organism's ability to rehabilitate. And these parameters or diagnostically significant indicators are the result of processing of a complex of signals, such as electrocardiogram, pulse oximeter, tonometer, and breath sensors. Next one, please. Refer to ACG signal. The most characteristic points of ACG signals are air peaks. There is wide range of algorithms for recognizing and extracting air peaks, and we have chosen widely used Pan-Tomkin algorithm. And this algorithm allows to obtain high sensitivity, specificity, and requires significantly less computer power. And based on the location of air peaks, the heart rate and heart rate variability values are calculated, was calculated based on the average value of error intervals, mean the variance of error intervals, this error, and the range of error intervals. Now we refer to pulse signals. The most characteristic points of pulse signals are Bay peaks. Bay peak is the first peak of pulse signal that forms in systolic period of the cardiac cycle. And we developed an algorithm based on the Van Tomkin's algorithm too, because this algorithm has the ability to detect maximums of pulse signals. And based on the values of amplitude of peaks and VV intervals, the average value of saturation, blood saturation is calculated. To measure blood pressure, we propose to use the risk manometer that supports data transfer to the sportsman mobile computer via Bluetooth. And for estimation budem rate, we propose to process signals from breath sensor. And the most characteristic point is the dominant frequency. And we use to extract this dominant frequency, we propose to use spectral analysis method that based on the calculation of the spectral power density. The next slide, please. And for comprehensive assessment of physiological reserve by the complex of parameters and the dynamic of the changes, we propose to use the scheme that implies measuring biomedical parameters at different levels of physical activity and sector pie chart. To form an integral parameter, these biomedical parameters must be presented in normalized form because the parameters may have different dimensions or range of changes, and normalization allows to represent them in one metric scale. After normalization, the value will change from 0 to 1, where 0 is the minimum of reserves and 1 is the maximum of reserves of level. And an example of the diagram of changing of integral indicator for different levels of physical activity is presented on the slide. This chart. To measure the integral indicator, we need to calculate the area of the polygon for each test. Here you can see a formula for calculating this area. The next one, please. Now let's talk about structure of proposed smart mobile system. It consists of, first of all, sportsman mobile device. It implements registration of the medical signals and preprocessing, since signals are recorded with different interferences. Then this device converts the signal into digital form and sent to sportsman mobile computer via Bluetooth. To measure blood pressure, we propose to use risk manometer that supports data transfer to the sportsman mobile computer via Bluetooth. The next block is sportsman mobile computer. It could be a smartphone or a tablet that provides processing and evaluation of sportsman physiological reserve level based on a complex of parameters. This information is used for assessing the dynamic of physiological reserve at different levels of physical activity. Then this information about current state of sportsman is transmitted via wireless network to server of Center of Sport Medicine, and then to coach mobile computer and to doctor mobile computer. Based on the information received, the doctor should make recommendation to coach and the sportsman about correcting the sportsman training program. The next one, please. Here you can see a prototype of this smart mobile system. The breath signals is received by using an inductive chest sensor. The electrocardiogram is received by using a single channel electrocardiograph. To fix physical activity, we propose to use accelerometer, and to obtain pulse signal, we propose to use sensor close pin that presented on the picture. The next one, please. And let's talk about our experiment results. Here at the slide, you can see some plots and one chart. Yes. The accelerometer plot showed the dynamic of physical activity of a sportsman. The heart rate plot showed the dynamic of heart rate, where the minimum value is about 70 beats per minute and the maximum about 150 beats per minute. After normalization, 70 will be equal to 1, and that value appropriate maximum of heart rate results. And 150 will be equal about 0.3, and that value appropriate minimum of heart rate result. If to collate plots and charts, we can see that increase of physical activity leads to an increase of heart rate, decrease of heart rate results. When we achieve the maximum of heart rate, the level of heart rate results becomes minimal, and this you can see on chart. This now I was talking about on the heart rate, but as I said earlier, we have a complex of parameters. That's why other parameters will change too when the physical activity increases. And thank you for your attention. I'm ready to answer the questions.
Thank you very much. Thank you for your presentation. We are waiting any question from our room. We also can ask question from chat on YouTube or chat from Zoom. Okay. In any case, I ask one question for you. I have one question for you. Could you say me about your mobile system, where you store data about patient, and could you send this data to cloud, or you store it on flash memory and copy to PC, and how long you can store information from one sportsman?
The information is stored in sportsman mobile computer. The block, the scheme that was earlier, and because sportsman can look at this device and understand his current state, and then this information from sportsman computer device can be sent to Center of Sport Medicine by wireless network. That's why we store information just for sportsmen and just for the to make him able to check his current state. And how long we are stored this information, I can't say, because it's we can decide it by ourselves. We just it's just prototype. That's why some points it's not developed yet.
Thank you very much. Okay, we don't have any questions from YouTube or other places. Thank you very much. We are going to the next presentation.
Thank you.
And okay, and next presentation, it's problem analysis. Fedor Dunev and Emilia Dominova. Are you here?
Yes. So Fedor is here, so I will tell.
Okay. What you prefer? Show presentation from your PC or show presentation from my PC and speech?
I guess it will be okay if you show and I just tell you when to switch on. It's fine.
Okay.
It's fine. Hello, everyone. Well, so let's start. Good morning, everyone. My name is Fedor. I'm a representative of St. Petersburg Electrotechnical University. And today I'm going to tell you about the problem analysis for creating an algorithm for detecting the episodes of epileptic seizures. So let's start. Next slide, please. So you can switch on to the next one. Thank you. So epilepsy is a disease of the brain characterized by repeated attacks of disorders of different motor, sensory, mental, or physical functions resulting from excessive neural discharges in cerebral cortex. So EEG is usually used to detect an epileptic seizure, but this type of diagnostics isn't quite convenient because of its complexity and exposure to third-party artifacts, although it is the most informative way to get the information about what's happening in man's brain. It has been established that epileptiform activity leads to changes in cardiac rhythm, in particular to the appearance of ictal tachycardia and bradycardia. So that's why the most obvious indication of changes in heart activity can be observed using the analysis of the heart rate variability, which is called HRV. So it is based on the calculation of estimates of statistical and frequency characteristics of RR interval sequences. So according to the above mentioned, the method for identifying the onset of an epileptic seizure is considered, which includes two parts. So the first part is the detection of pathological changes in patients' ACG caused by epileptiform activity by passing the signal through a high frequency filter with a high cutoff frequency, more than 100 Hz. And the second step is that HRV characteristics are calculated to decide if there is an epileptic seizure or not. So next slide, please. So in total, there are four main research methods in which the EEG is taken as a basis. So let's speak at first about EEG and seizure detection. So the first method is a routine EEG research. Second is a real-time video monitoring with EEG research. Third is a polysomnography. And the last one is a Holter EEG monitoring. So real-time video monitoring with EEG research is the most informative way, but the less convenient because of its length. So it should be at least 30 minutes long, and because of its complexity, because when you need to make an EEG research, you need at least 19 deflections to put on a patient's head. So the advantage is only one, but very large one, because it's a very informative way to discover epileptiform activity. But the disadvantages are the difficulty of capturing the electrical signal. This means that you need at least 19 deflections to make an EEG research. So the duration of the analysis, it should be at least 30 minutes long. Sometimes, for example, in case of real-time video monitoring, it is usually like 3 hours long. And the last but not least, that the amount of information can only hinder the analysis and slow down the processing speed. I mean that, it's really informative way to get information, but sometimes you don't need this amount of information, and it can only slow down the processing. So the next slide. So let's speak about ACG and seizure detection. So numerous studies report that at least 50% of reported epileptic seizures reveal different type of cardiac arrhythmias, and the main role in the emergence of arrhythmic syndrome and epilepsy is played by dysfunctions occurring in sympathetic and parasympathetic nervous systems, and combine membrane shifts in structures of brain and man's heart. So several studies have found that sinus tachycardia occurs at least at 50% cases and can be detected. So the advantages of ACG, that ACG research method is simpler than EEG one because you need at least one deflection, not like 19 in the EEG case. The absence of numerous patterns. So to detect an epileptic seizure using EEG, the doctor usually needs to discover specific patterns, and it depends only from experience of the doctor. So if the doctor is experienced, he can find these patterns, but if not, it's quite difficult. And of course, ACG can be processed much more faster than EEG because it's not so, let's say, not so informative, not such amount of information. So the disadvantage, the main disadvantage is that sinus tachycardia can be caused not only by factors which cause an epileptic seizure, and it's so ECG is not so informative as EEG research. So next slide, please. Now I'm going to tell about what is HRV analysis. So it's a method of studying the statistical and frequency signals properties, which is formed by a sequence of time intervals between adjusting heartbeats called RR intervals. For its calculation, the next sequence of operation should be completed. So the first is that all heart rhythm disturbances or interference causing errors in determination of RR intervals should be deleted from the analysis. Second step is getting a sequence of NN intervals. NN intervals, it's intervals between adjacent QRS background rhythm complexes. So RR intervals aren't directly used for this analysis. It's very important. Third step is the restoration of heart rate control function in the form of sequence using the spline interpolation method. Then the calculation of power spectral density estimation happens, and the calculation of HRV indicators is happened so using the formulas below. So there are three indicators: VLF, LF, and HF, which means very low frequency, and high frequency. So the next slide. So here is an algorithm, which it looks like. I guess the picture is okay. So the pre-processed ACG record is loaded into the program, which works according to this algorithm with at a sampling rate of 250 Hz or 500 Hz. We usually 500 Hz is the most suitable for ACG. Then the signal is passed through the digital high frequency filter with a high cutoff frequency more than 100 Hz. The frequency selection is based on the position that the useful component of ACG signal lies in the range of 0.05 100 Hz. And the amplitude threshold is set at level of 0.5 millivolts, so this threshold was determined experimentally. So the presence of sharp teeth and bursts of high amplitude more than the threshold, more than 0.5 millivolts in a filtered signal exceeding the detection threshold gives us a warning that there is a tachycardia, and it's the reason to move to the second stage of detection, HRV analysis, which I told you before. So next slide. So the conclusions are the main idea that we can use methods which are quite simple if we're speaking about the mathematics, and it will allow us to create a software which won't require a PC with a high performance for its using. But there are also some problems which should be solved in the future. So the first and the main problem is that to provide enough data to check the correctness of the algorithm, because when we're speaking about like a Holter monitoring in case of an epilepsy, so Holter monitoring is like 24 hours research, but an epileptic seizure can last like only 2-3 seconds. Sometimes it can be 30 seconds. That means that we need to find enough patients. And the second is that the minimizing the erroneous triggering of the algorithm. So we need to find right markers which we can use in epilepsy, an epileptic seizure detection. And it should be unique. I mean that they can mark an epileptic seizure, not something else. I mean, not some different activity of cardiac system. So that's it. Thank you for listening. I'm ready to answer your questions.
Okay, thank you very much. We're writing questions for this presentation in YouTube and in Zoom chat, and also we obtain one more questions about previous presentation, and I will ask them in break time. Okay, I ask first questions, and we stay waiting for other. My first questions about physiological physiological basis for your research. I see that you use ECG for predict epileptic seizures, and how it can work, and does any other system exist, and what is its specificity and sensitivity, and does it possible at all?
Yes, it's possible. So there are numerous studies about how to detect epilepsy through ECG. Well, some of them are not quite, let's say, lucky, because there was like 20 cases of an epileptic seizures and only in 3 cases it was successful to find an epileptic seizure. But some of them are really impressive. It was I don't remember which one, but it was a nice research that in 95% cases it was success to find an epileptic seizure through ECG. So in the future, we're going to make like a smart system, which will be like a small box, like even smaller than a Holter monitor, which a patient with an epilepsy can wear, and a mobile app. So in the mobile app, it will be like, well, when the patient is going to have an epileptic seizure, this app will make like a notification on his phone that, well, you're going to suffer an epileptic seizure, so be ready. So he can take medicine. He can be just prepared for in this case, because, for example, if the man suffers an epileptic seizure somewhere outside, so he can fall down, and for example, he can fall down on the road or something like that, and well, it can be quite dangerous. So that's it. And the second, so the one mobile app will be for a patient, and the second app will be for a doctor, which can so the doctor can see if the treatment is going quite well or not, and if not, so he can change some medicine or something like that.
Thank you very much. Okay, I have one questions about second presentation in YouTube. Presenter asked me, could we show the presentation? I suppose we can make this in the end of the day. I answer on these questions. In the end of the day, we have some time. Sorry, or we can insert additional presentation in after lunch. After lunch, it's here. Sorry, May 14. Okay. I wait some questions in chat or other places. Okay. Presenter of the third presentation, are you hear me? The previous presentation, are you here? Sorry. Does we have is the presenter of this presentation? Okay. Yes. Are you hear me? I want to ask question from YouTube. What is quality of your ECG signal?
The quality of ECG signal is satisfactory, but it is sufficient to extract the error peaks and calculate the proposed parameters. At the moment, we are working on an algorithm for more pro-cleaning of the signal from interferences. Because it's just prototype, that's why the work is still we're still working on it.
Okay, so thank you very much. I stop sharing my screen. And currently we have some break time until 11 a.m. 15 minutes. And after this, we start second part of our section. And I ask Vladimir Sholokhov help me with screensaver. Vladimir, are you here?
Yes.
Okay. Please share your screen with break screen. And also you can send me changes in your presentation in Zoom chat. If you send it to me, I replace your presentation now, and we start after break. I stay stream and presentation, stream and Zoom meeting opened, and you can freely speak and discuss presentation as this happened on any conference. Yeah, please. And also you can, if you want to ask privately, you can ask question in Zoom chat, because Zoom chat can send some messages directly to user without public availability. Okay, we will invite you after the break. Hello? Dear, we start after 2 minutes. I want to check that our presenters is there. Are you hear me?
Yeah.
Okay. I ask about presenter. Okay, I will read name of presentation, guaranteed defibrillation on academia side model.
I'm here.
Dependence of the left ventricular ejection fraction on the myocardial fiber orientation and so on. Are you here? Optimization of endocardial electrode position to enhance cardiac resynchronization therapy. Okay, I ask about presenter. Okay, I will read name of presentation, guaranteed defibrillation on academia side model.
Please mute Anastasia.
Dependence of the left ventricular ejection fraction on the myocardial fiber orientation and so on. Okay. Optimization of endocardial electrode position to enhance cardiac resynchronization therapy. Excuse. Okay. Okay, I will read. Okay, and I ask about the. Okay, I last presenter. It's me. Okay, perfect. We start after 1 minute. First presenter. What's your choice? Read presentation from my side or show presentation from your PC?
Your PC.
From my PC?
Yeah, your PC.
From my, okay, perfect. Okay, we start from this presentation.
Okay, I can start.
Yes, you can start.
Okay, thank you. Good afternoon, dear colleagues. I want to present my work, Guaranteed Defibrillation on Cardiomyocyte Model. Despite the considerable period of experimental and clinical use of pulse defibrillators, there are still no complete clarity this mechanism of heart defibrillation. The aim of this work is more detailed study of defibrillation mechanism and comparison with available experimental data to confirm the representation that guaranteed defibrillation mechanism is external defibrillation mechanism. Next slide, please. The study was carried out in beatbox simulation environment on 10 tissues panfield model of human heart ventricular myocyte for two pulse forms, half sine and radical. In this study, pulse energy was calculated during the simulation. The risk of cardiomyocyte in state of simulation fibrillation to effect of depolarization current pulse was evaluated. Simulation of fibrillation was caused by excitation impulse of 0.5 millisecond duration with frequency of 240 Hz. In determining the threshold of guaranteed defibrillation, the defibrillation pulse acted on cardiomyocyte model immediately after exposure to excitation impulse. The threshold amplitude of defibrillation pulse was fixed when excitation of cardiomyocyte model was suppressed at action in the next excitation impulse. Next slide. The result we checked for compliance with law Hoover-Weiss-Lapik present on this slide. Next slide. For half sine and reticular excitation impulse depends the threshold excitation energy of cardiomyocyte model on excitation impulse duration we constructed. This depends in shown in figure. The values of pulse duration relative to duration, the energy optimal, the duration optimal pulse depending the threshold value of excitation energy of 1.2 emin and 1.5 emin present in table. Curve that depends of threshold excitation energy on duration the excitation impulse correspond to Hoover-Weiss-Lapid law only in first approximation. Deviation of curve that depends the threshold excitation energy on Hoover-Weiss-Lapid law depends on where of impulse. Next slide. Dependence of threshold energy of guaranteed defibrillation on duration acting half sine and in reticular pulse present figure 1 and figure 2 respectively. For rectangular pulse, minimum energy coefficient of guaranteed defibrillation is 23% higher than for half sine pulse. The ratio of duration of energy optimal pulse of guaranteed defibrillation to duration of energy optimal excitation impulse for half sine waveform was 2.37 and for rectangular waveform 2.42. Next slide. The values of pulse duration relative to duration of energy optimal pulse depending on the threshold energy values of guaranteed defibrillation of 1.2 emin and 1.5 emin present in this table. From previous two slides, it's follow what for cardiomyocyte model. In first approximation, curve of depends of the threshold energy of guaranteed defibrillation on the duration. The defibrillation pulse correspond to Hoover-Weiss-Lapid law on limited range relative values on the pulse duration. For rectangular pulse, this range is much higher than for half sine pulse. Next slide. The result obtained of half sine pulse seems paradoxical. However, we can compare this result of animal experiments. The result of experiments on defibrillation with monophasic half sine and biphasic quasi-sinusoidal pulse are present in table. Unfortunately, model of cardiomyocyte are imperfect. For half sine pulse in cardiomyocyte model, the energy optimal duration was 53 milliseconds as indicated above, and according to the result of experiments, it was 5 milliseconds. Therefore, to compare the data, diminishes values of the duration relative to duration of the energy optimal pulse were used. Figure represents the comparison result. We dots represent the average values of result. As can be seen from figure, the result obtained of cardiomyocyte model are close to result obtained in animal experiments. Next slide. Next slide is main result and conclusion. Thank you for your attention.
Okay, so thank you very much. Thank you very much. We are waiting question from our participants, and I ask first questions because some people have no time for react and write questions.
Okay.
I want to ask you about time of about performance of your solution, because when we calculate cardiomyocyte model, we should introduce some changes in differential equation or in algebraic equation, which we solve during the simulation process. And does it's how this solution affected on performance of the solver?
Oh, please repeat, please, your questions. I understand you.
When we calculate some cardiomyocyte models and make some simulations, we need to introduce a method of activation into the algebraic equation in your model. And usually it happened with usual impulse wave in some time. But when you introduce your approach, how it affected to performance of the computational cost of your simulation?
Okay. I think I don't answer these questions.
Okay, thank you. I'm writing question from chat or other participants. Maybe we have problem with some configuration. Okay. We have no other question. I suppose you can speak on break time or other time, and we go to the next presentation. Next presentation. Vladimir, are you here? Vladimir? Okay, perfect. Vladimir, we can't hear you.
Hello?
Hello?
Yes. Good morning, dear colleague. My name is Vladimir Sholokhov. I am a PhD student of the Ural Federal University. My report is dependence of the left ventricle ejection fraction, the myocardial fiber orientation in the mechanical model. The work is devoted to a key indicator of the human cardiac performance, namely to the left ventricle ejection fraction. The behavior of the left ventricle ejection fraction as a function of two model features investigated. Action potential duration in cardiomyocytes and myocardial fiber orientation in the ventricular wall were chosen as variable parameters that may influence on the ejection fraction. On the slide, you can see the pipeline of the building the 3D model of the left ventricle. In our work, we used patient echocardiography data to create personalized isosymmetric three-dimensional model of the left ventricle of the heart. We use a 6-parametric model to approximate the shape of the left ventricle. In general, the geometric parameters satisfy two criteria of normal healthy human, according to the clinical echocardiography guidelines. Geometry consists of finite elements tetrahedron. The orientation of the fiber in the model was set using rule-based approaches. The algorithm is based on the solution of the Laplace equation. Action potential generation and propagation of the excitational wave in the myocardium together with active tension development in cardiomyocyte was described by Nash-Pamphilov model, where U is transmembral potential, V is reverse conductivity, and TA is active tension. The active tension of cardiomyocyte is transferred to a TCU model of myocardial mechanical function with assumptions that It acts along the fiber direction only. Let us introduce some definition for a mechanical model. It's a left Cauchy-Green tensor, the format structural tensor where F is deformation gradient, M is a tensor of fiber anisotropy after deformation. The model includes passive and active part of Piola-Kirchhoff stress tensor. The active part of stress is related to force which generated by cardiomyocyte according to the Nash-Pamphilov model. The passive part reflects the isotropic stress response with Lamé coefficient lambda and mu. An isotropic mechanical parameter nu can be considered as a passive stiffness of myofiber. On this slide, you can see different activation type. First is activation in points, in other points. Second is activation on subendocardium surface, and third is activation on the entire volume. Models were computed with following boundary and initial condition. Transmembral potential equal 0 in points of electrical activation, equal 1, equal 0 is in other point. Here we simulated LV contraction under the constant external pressure equal 80 millimeters of mercury. Displacement equation were solved the finite elemented method on the tetrahedral mesh. Displacement of the basal ring of the left ventricle were restricted to prevent left ventricle displacement. Computational time step was 1 millisecond, and algorithm of solving was implemented using Phoenix computational package for Python, and for visualization we used program ParaView. Previously we tested the effect of point activation on the ejection fraction. When activated at different longitudinal position on the endocardium wall, the high ejection fraction is observed for the activation point in the middle segment of the left ventricle. It shows the contraction of the left ventricle at different point in time. The left picture is side view, right picture in apex view. And on the right image, you can see the twist of the left ventricle. This picture shows a twist on the left ventricle. X-axis is a point from apex 0 to base 11. Y-axis is a twist angle percentage. Maximum twist angle closer at apex, near 33 degrees. On this slide, you can see strain over time. We get points from apex to base for free line, endocardium, midline, and endocardium line. We looked at Green-Lagrange tensor main components in these points and take the average between them in one line and get longitudinal strain over time, circumferential strain, and radial strain. And we move on to the main task of work. The study was performed using a population of model approach. It means the following we related to model parameters defining myocardial fiber orientation in the alpha 1 is endocardium fiber orientation angle alpha 2 and epicardial fiber orientation angle, and one model parameter defining the action potential duration in cardiomyocyte B. And calculated model output set each combination of the three parameters. Parameter alpha 1 and alpha 2 were variated throughout substantial ranges that were far beyond on the normal physiological ones. The last parameter B provides the RPD in the model from 180 milliseconds to 440 milliseconds within the physiological range. In the parameter space, we choose 100 point with random uniform distribution. Sampling was performed using the Latin-Gipper method. The ejection of each independent experiment provides one ejection fraction value calculated as a fraction of 60 degrees in the left ventricle volume. The ejection fraction is a measure expressed as a percentage of how much blood the left ventricle pumps out with each contraction. Result computation were interpolated in the parameter space using the radial base function interpolation method with Gaussian function interpolated kernel. Result of interpolation are shown in this figure. Show the influence on the fiber orientational angle and action potential duration on the left ventricle ejection fraction. Computed value on the ejection fraction are in the range of 43% to 77%. It is notable that a high value of the ejection fraction up to maximal 77% reaches this point. On this slide, you can see show distribution of ejection fraction value for a different action potential duration at 19% repolarization. The mean value of ejection fraction increases from 55% to 63% in action potential duration, this range, to 388 milliseconds. Surprisingly, the mean ejection fraction decreases from 63% to 57% in a range of long action potential duration from 388 to 430 milliseconds. To obtain a new result, we have already used 150 points in a parametrical space. On this picture, a point of activation is a Basel ring. We have identified the normal range of fiber orientational angle in this article. Mean value is 66 for alpha 1 and minus 41 is alpha 2, and deviation is this. We get a box plot of the ejection fraction distribution of various action potential duration at different sigma interval. And we have put various experiments, use different type of activation. Various fiber orientation may provide significant different range of the ejection fraction for divergent action potential duration and fiber rotational angle. However, the method of ventricle activation is not so important for obtaining ejection fraction. Our models show the following ranges between minimum and maximum value across near 54% to 78% for the all. Then to sum up, interesting point is the green arrow. And notice to the additional local maximum basal activation, or only basal activation near to 200 milliseconds. To sum up, the action potential duration increase lead to an increase in the LV ejection fraction. That is a well-known fact. However, this dependence has a saturation point, red arrow. And increasing the APD above this level lead to reduction in the ejection fraction. The fiber orientation affects the ejection fraction, which can be important part of physiological factor under the geometrical remodeling of the left ventricle. Reduction is the ejection fraction is a heart failure may be caused not only the cellular remodeling and action potential duration changes, but also the change in structural ventricle of the ventricle wall. In conclusion, we provide some computational experiment for analysis of the dependence of the left ventricle ejection fraction on the myocardial fiber orientation in the mechanical model. The inter-subject variability of the ejection fraction that is observed across the human population may be fully explained by the variation of fiber rotation in the left ventricle. Personal feature of cardiomyocyte electrophysiology, mechanic, or LV geometry make some effect, but these effects are not necessary to explain of the ejection fraction variability across the human population. In our model, the location of the ventricle activation point weakly affects the cardiac output. However, we notice that some arrangement of the fiber may be more effective for every shot, only basal activation and very wide action potential duration. The model will be combined with the blood circulation model for more realistic simulations. Thank you for your attention.
Thank you very much. Okay, I'll ask one questions because we are writing questions in YouTube and in Zoom chat. Vladimir, what do you think about effect of lungs contaction with pericardium and effect of blood pressure in right ventricle on the myocardial mechanics?
Repeat, please.
What do you think about effect of blood pressure in right ventricle and effect of contact of lung and pericardium on the myocardial mechanics?
Okay. Affect blood pressure right ventricle on the mechanic of myocardial is very much, and we in future we add right ventricle in our model for get this result and forget this result.
Thank you very much. We are waiting other questions because we have 5 minutes and okay. Currently, we are waiting the third presenter. Presentation optimization of endocardial electrode deposition to enhance cardiac resynchronization therapy response and in silico study. Presenter of these presenters, are you here?
Yes, here.
Okay, are you sharing from your screen, or I show your presentation and you will speak?
I want to share from my laptop.
Okay, we are waiting you. Please start.
You can see something.
Yes, thank you very much. Thank you.
Hello, my name is Anastasia. I'm from Ural Federal University. Let's start. Cardiac resynchronization therapy is procedure of implantation patient electrodes in the left and the right ventricle of the heart. Cardiac resynchronization therapy is recommended for patients with chronic heart failure. After this procedure, quality of life improve. As a success of CRT procedure, the blood ejection fraction from the heart increase, and doctors can see it at the ECG signals. But unfortunately, about 30% of patients don't respond to this procedure. The main reason of CRT failure is electrical dysynchrony between heart ventricles. The CRT failure caused by non-optimal location of the stimulation electrodes at left and right ventricles. So the aim of our work was detecting the optimal position for passing electrodes, and we tried maximization of CRT procedure. For our in silico study, we used clinical data for 35 patients. This data was provided to us by St. Petersburg Almazov National Research Center. These data contains computer tomography images, also magnetic resonance imaging, and we have information about accurate location of the passing electrodes for each patient. And as a slide, you can see our pipeline for building patient-specific geometrical model. At the first step, we reconstructed surfaces for torso, hearts, and lungs from computer tomography data. And the next step, we got a finite element model for hearts, lungs, and torsos. At the next step, we reconstructed a fiber direction in each heart point. And the next step, we calculated activation map for all hearts. And the last step, we calculated potentials in each point of the torso, and we calculated ECG signals. For calculation activation map, we used a canal model, the governing equation system you can see at this slide. TA, its time, it's local activation time in the each heart point. At this picture, you can see example of calculation total activation time and local activation time in each point. For ECG calculation, we used pseudo-Bidomine model. The governing equation we can see here. We calculated transmembrane potential, it is VM. We got VM from Tintusher model von Philip. This model describes electrical function for human cardiac cell. There is action potential of Tintusher model von Philip. After calculation pseudo-Bidomine model, we have such ECG signals for each patient. At this slide, you can see examples of patient-specific geometrical models with heart, torso, and lungs, and also positions of electrodes for 12 leads ECG signals. In our in silico study, we have information about accuracy passing electrodes position, just like this figure. In our study, we varied electrodes position for each patient. In the right ventricle, it's white. It's a 3 white points, and the left ventricle, it's 18 position. So for each patient, we have 61 different combinations of passing electrodes. Since the 30 results and 30 success connects with shortening of total activation time and QRSD duration, we calculated such parameters for each patient. In the end, we compared total activation time and ECG and QRS duration in case of original electrodes position, and in case of model electrodes position. At this slide, we get the result of our modeling in case of total activation time. The red hat line, it's total activation time for original location of passing electrodes. The blue line, it's better results for modeling electrodes position. How you can see, we got a combination of passing electrodes which improved results for most part of patient. At this slide, results for QRS duration. The red headline, it's QRS duration in case of original electrodes position. The blue line, it's results for modeling. As the previous result, we improved QRSD for the most part of patient. Also, we detect regions for best pacing for 30 electrodes. Here results for total activation time. Here results for QRSD duration. As you can see, these results are very similar. As a conclusion, we showed that combination electrodes in the ventricles can improve CRT results for the most part of patient. We detected the best position for patient electrodes. You can see it at this figure. But for the same patient, the best position for CRT electrodes in case of total activation time and QRS duration can different. So there rise a question about the best CRT success marker. Thank you for your attention.
Thank you very much. We are waiting questions. I ask first. It's a really great job. Really great work, because I see a lot of experiments here and a lot of work. And I want to ask you, what do you think about cardio stimulation with electrodes that contain several tips and can be programmed for provide activation in different points along the implanted electrode in left ventricle?
Excuse me, can you repeat?
I want to ask you about alternative way of for endocardial stimulation. It's electrodes which implanted in coronary vessels and contains several tips, contains several points for stimulation, and mode of stimulation and program of stimulation may be programmed after the implantation of this device, and provided advanced approach for improve CRT quality.
I know that CRT settings exist after this implantation. Theoretically, in our model, we can set delay between electrodes, and maybe we can determine the best delay for electrodes for each patient. Maybe as a result, we got the best position for CRT electrodes at epicardial and endocardial right ventricle, but we must to set optimal delay.
We can't hear the moderator because he switched off his microphone. Konstantin, shall you switch on your microphone? We can't hear you.
I'm sorry, I'm lost connect with conference. I hope the answer was full and cover my questions. I'm sorry for this. we have no other questions in YouTube channel or in chat. For this reason, I'm goes to the last presentation of this block. It's my presentation. I hope you will criticize me and say more, give me more, how it named, more critics for me. Okay. Okay, so sorry for some troubles with connection. Okay, I start. I'm glad to see you on my presentation. My presentation is new technology which can replace current approach to phase mapping, which is suitable for analysis of clinical data in electrophysiological studies. I explained some background about human electrophysiology. Cardiomyocytes provide action potential on his membranes, and when a lot of cardiomyocytes in tissue in one times generate active action potential, it's lead to excitation wave on the myocardium. And if we place electrode on the myocardium, we can register the extracellular potential from the heart. That's directly happened in clinical practice during the electrophysiological studies. What is phase mapping? Phase mapping is approach for analysis of complex non-stationary behavior of myocardium. When in myocardium happen complex reentering process, we can read some data from each point, transform it with Gilbert transformation and phase transformation into phase signal, and use these phase signals to provide new visualization results like presented here. It's a work of Nuttall. It's one of the last work in these topics. In the top row, we see significantly some images about electrograms on the heart surface, and it's very difficult to understand what's happened here. On the second row, we see phase maps. Phase maps provide you a clear phase front. It's excitation. It's a start of excitation wave, and also it's provide a rotor. It's place when the spiral wave or rotor rotated in the myocardium. On the right side, I show ventricular tachycardia model. This process happened during the life treatment condition. Our motivation to study. If we take transmembrane potential, we can build a very good phase map because it's possible because action potential is really very similar to each other, and signal is not variated significantly. But extracellular potential is very different, and in sometimes its phase signals goes too close to initial point of phase plane, and it leads to rise of some artifacts on phase mapping. This happened in clinical practice, and this happened in experiments, and also we can repeat some of these artifacts in our simulations. And our idea, usually phase mapping based on the simple idea. We take signals from several points of myocardium. Usually it's unipolar recordings or bipolar recordings. These recordings provide us some information, and we use amplifier. We amplify it and take discrete and make discrete transformation for processes in like digital signal processing way. We process each signal separately, and after we use some algorithms which present us all activity like a map or like a video on the heart surface. Usually it's happened only in small part of ventricle or atriums of the heart, but in models we can present a very good images which you see here. And usually we process each signal like a series of mathematical transformation which clear our signal and filtering it. And our approach, we generate some data sets from simple mathematical models, train neural network, and after we use neural network for process these signals. And my work is proof of concept that this approach may work in real practice. We make some proof on simulations, but we hope this approach also can work in with real signal. On this slide, we see results of phase mapping. And from my point of view, we can introduce more robust signal for visualization, because we need only break of signals on the front of excitation wave. And also we need a linear and monotonical decreasing of signal from one excitation wave to other. And we introduce a simple sawtooth signal which goes from first point to second point. And we can generate it in model from transmembrane potential without any problem. Okay, methods, artificial data. We use Ten-Tuchel Noble Panfilov model. It's a good model of human ventricular cardiomyocyte, and we calculate 1D myocardium model with for provide some signal of pseudo ECG. Equation which we present here also can provide signals which is very close to unipolar electrogram if we change some parameters on this equation. Neural networks, we generate about 50,000 signals and send it to neural networks. Like on input we send extracellular potential, and on the output we send our PLT signals. And this is usual UNet architecture with some changes. We directly this make not segmentation of image, but we make we solve regression problem for translate one signal to other signal. And we change basic laws to MSE and mean square error and mean absolute error. And also we add strong dropout and strong Gaussian noise in narrow layer for make this solution more robust for noises. Here I present training. We use reduce on plateau approach, and we can see table with some results of metrics. Oh, sorry. Yes, we use not so much number of cases. I make mistake in previous slide. We use only 150 training signals, and on the test we use full personalized model. This is results on training data sets. Red lines, it's extracellular potential, which we obtain from simple 1D model of the myocardium. And we suppose it's a very different, and some of them looks like signal from clinical practice. Some looks like a signal from atrial flutter or ventricular flutter. and some of them looks like absolutely crazy, but it's not so important because we cover, from my point of view, we cover all possible signals which we can obtain. And we normalize the signals in range from -1 to 1. Black line, it's our expected phase-like transformation, PLT signal, and we obtain it directly from transmembrane potential from a simple definition. And green line, it's prediction of our neural networks, which take extracellular potential and provide us PLT signal. For test data set, we use personalized and detailed model of human electrophysiology. This model provides ECG and was verified against 20 signals from real patients. For this reason, we think that it's very close to real human electrophysiology. And here you can see maps which were obtained on the surface of ventricles in this model. You can see our approach to phase mapping, and this approach directly repeat real front of activation wave, which presented like transmembrane potential. And also you can see that scores of rotors located in the same point like it happened on transmembrane potential map. Our conclusion, we propose a new method for phase mapping, and this study was supported by Russian Foundation for Basic Science, for basic research. Thank you very much. I'm waiting for your questions.
Hello, everyone. I have a question. My name is Olga Solovyova.
Thank you.
Very impressive. So actually, I have two questions. First is, how did you do abnormal ECG signals in your model?
Okay. You ask about this. Okay. In this equation, we can change conduction velocity in 1D model. We can change position of electrodes near to myocardium, and if we raise it up or goes down, it's produce a very different unipolar electrogram. We can found, if you ask me after in chat, I will send you article published in 26 year, 26 yes, which shows that this model this simple model can repeat all electrograms which can provide from myocardial monolayer. And if we vary parameters of this model in strong range, we can provide all available signals. And also in my article, which I sent to this conference, I make a link to clinical work which show signals that is very close to some of my signals.
Okay, so and you showed the results of phase mapping with spiral wave. So your model reproduces spiral waves in.
Yes, we use this model of human electrophysiology, and we use S1 S2 protocol. It's two stimulus protocol which rise spiral wave on the myocardium, in the ventricular myocardium, and also we test this solution for usual point activation. But it's not so interesting. But we not present these results because phase mapping usually used only for reentrant activity, for complex non-stationary behavior or in the myocardium tissue.
Did you try to use this approach for realistic clinical data?
I hope. Currently, I have no time for this, but I'm glad to use this approach to any clinical data, and I will be very happy if you will provide me this data.
Okay, thank you very much.
Thank you for everybody. We goes to lunch. Vladimir, could I ask you to show us a break screen? Vladimir? Okay, thank you very much. We goes to lunch. If you want to change your presentation, you can send it to me in Zoom chat, and I replace and will show what you want. And also I goes to this room 5 minutes before start of the next slide, and I will check presenter of the next block. Thank you very much. Vladimir, are you here? Dear participants, we should check presentation and presenters.
Добрый день, Константин.
Hello.
Hello. This is second section.
Yes, second section.
Yes. I have presentation number 10.
Endovascular biometrics.
Exactly.
Perfect. Dear presenter, could we find some people who present control of treatment in tumor dynamical model with hysteresis?
Yes. One question about presentation. Presentation auto switch?
You can use.
Switch on.
You can show your. You can show
my presentation in my profile.
You can show presentation from your PC, or I can show presentation from my PC, and you will speak only.
Okay.
Two options.
I need just reading.
Okay.
Yes.
In this case, I show presentation like this, and it will be available for all. Okay, I need to check other presenter. Dear all, we waiting for Lev Lishko.
Okay, I'm ready.
I'm ready. Perfect.
Yes.
Perfect.
Is it okay with my slides collection?
I see your presentation here, but if you want, you will share your screen and show from your computer.
No, let us use standard possibility from computer of administrator. Yes.
Thank you very much. And also, I'm search for presenter of determination of tissue properties based on modeling and electrical impedance registration.
Hello, Konstantin. I'm here. I'm the
Perfect.
speaker for 12 presentation.
Perfect. You will present from your computer or from my computer and will speech?
Let's show it from your computer. Thank you.
My computer. Perfect. Okay. Also, I'm search for Indira Valyeva because she want to bring his presentation to other time slot. Are you here? Not here. Okay. In this case, we can start from presentation of Lev Rishko, Irina Baktisheva, and Irina Beshkirtseva, and Miguel Sanjun. I'm ready. Do you see my screen?
Yes. Okay.
No, you don't see my screen. Okay, sorry for this trouble.
Oh, fine.
Yeah, perfect.
Yes, first slide is okay now.
Perfect. I suppose we can start if you're ready.
Yes. Let us start. Okay. Are you ready? I am begin. So, dear colleague, I would like to present my comment to this presentation devoted of treatment in tumor activity. I would like to explain some our new mathematical idea and application to this essential medicine problem, really for everybody, not only for scientists, for standard human, of course. This investigation was prepared in collaboration between our research group named Stochastic Nonlinear Dynamic of Ural Federal University and another group, Nonlinear Dynamic and Chaos in University Madrid, San Juan. Miguel is the leader of this group. Our collaboration was produced near 1 year, and this one of the recent results devoted the problem of treatment of tumor. Now, it's well accepted that the combination of chemotherapy and radiotherapy is a beneficial strategy for the treatment of many solid malignancies, as, for example, the treatment of low-grade glioma or lung cancer. Apart from the minimization of the toxic side effects impaired by drugs and radiation on heavy tissues, as well as the avoidance of the development of tumor resistance through clonal evolution, the particular strategy that is adopted then arranging the schedules of treatment protocols can be of great relevance as well. The main question is what doses of the chemical and radiotherapy are reasonable, and what timetable is optimal in this combination.
Excuse me. We stay on the first slide now. You don't ask me about.
Yes, okay, it's sufficient. First slide. I will ask you to change if it will need. In this talk, we consider the problem of the treatment control combining chemotherapy and radiation therapy. In our mathematical analysis, we use a dynamic model represented tumor cell behavior in presence of both variants of therapy. For this model, the bifurcation analysis reveals different parametric zones, these active and dormant tumor levels, where the system exhibits specific feature of hysteresis. The results of this bifurcation analysis are used to study the effectiveness of treatment. Strategies of treatment control combining chemotherapy and radiation therapy are discussed. We show how presence of hysteresis should be taken into account, then control treatment strategy is chosen. Please, next slide. Okay, this is a very simple conceptual model for tumor dynamic, where X is the density of tumor cell, C large is the concentration of drugs, and B is efficiency of drugs. Another variable is not essential, they are fixed in our consideration. Please, next. The first question is how drug affects tumor. Of course, if we C equals 0, so we have not applied the chemotherapy, then X of t tends to some fixed stable equilibrium X bar that is close to unit. Rarely in our talk, quantity of tumor near unit mark so-called active tumor. It's a bad case. If X near 1 is a bad situation, is an active tumor, AT, I will use this short notation. Of course, if we applied the concentration of drug C greater than 0, in accordance with application, tumor density will tend to another value, X tilde. And we're interested about condition when this X tilde more smaller than X bar. If this stable state X tilde will be sufficiently smaller, this state X tilde will name dormant tumor. In our model, there is no possible to vanish tumor absolutely. Everywhere the some value of a small piece of tumor presence in the modeling body. So two state active tumor and dormant tumor now is the two main point of consideration. Last picture present parametric diagram where axis C is drug concentration and B is parameter of efficiency of drug, and according to these ties between C and B, we can observe three parametric regions. Upper region, dormant tumor, it's fine situation, but in order to catch this situation, in order to use sufficiently large C and B. Bottom zone, yellow color, is active tumor. In this zone, we have no possibility to reduce tumor. Another, between dormant tumor and active tumor zone blue is the zone of a special our mathematical interest where coexistence of two states, stable state of tumor density are present. On the right picture, we observe many curves, different color, which correspond to various values of B and C. Please, next slide. Okay. Let us discuss how efficiency of drugs affects tumor. Here we consider three values of B. B equals 1, low efficiency drug, B equals 2, middle efficiency drug, and B equals 4, high efficiency drug. Correspondingly, for these three variants of drug efficiency, we can observe three different types of tumor dynamic. On the top figure, we observe only one line, green line, corresponding to active tumor. These lines slightly decrease as C increase. It means that such type of treatment is ineffective absolutely. Really, for this type of tumor with B equals 1, our treatments is useful, is not useful. Next picture, B equals 2. So sorry, back in the picture. small picture, not slide.
I'm sorry.
Okay. Let us consider another type of drug with B equals 2. Here we observe two levels of tumor stable state. Upper level active tumor and bottom level is dormant tumor. The difference between this stable value of tumor more than 2 degrees, yes, left scale will help you to divide what is the real difference between these. The zone of B stability is essential for understanding real dynamic, because in the condition of the B stability, the real observed state is dependent on the initial state of tumor density. If our initial state belongs to basin of attraction dormant tumor, of course, on the increasing T, we have catch dormant tumor stage. But otherwise, if initial state belong upper zone, we have only observed the bad case of active tumor. Right, a small picture. This type of active and dormant tumor move to the left, and we have observed so-called hysteresis. Hysteresis is well-known word for mechanic from magnetism and so on, but such type behavior named hysteresis can be observed in this tumor dynamic model. It's essential that if we increase C from the left to the right, it's possible to jump down from active tumor to dormant tumor. This jump can be catch and it's possible to come back to smaller the drug concentration in order to prevent body from unexpected feature. Next slide. Really, we consider control of treatment. We would like to compare two types of treatment. Blue means chemical therapy, red is intensive radiotherapy. Radiotherapy is well-known strong influence of body, then it's possible to reduce immediately the size of tumor. left picture describe how this combination chemotherapy before it's possible to move our active zone from the left to the right, where destability zone will absorb. And only after this transition is possible to apply intensive radiotherapy and jump from active tumor upper branch green curve to lower tumor corresponding the dormant tumor. Right picture exhibit how organize the treatment with use only chemotherapy. Please, next slide. In this slide, we compare two variants of schedule of treatment. How combine blue chemical therapy and red intensive radiotherapy. Compare this small picture. The bottom parts of this picture present the timetable of application intensive therapy marking by red triangle and chemotherapy marking blue curve. On the left, we see the program before radiotherapy and after chemical therapy. On the bottom part of left picture, we observe result of this treatment program. As we can see, in according to this application of radiotherapy, the level of treatment dropped down, green. But unfortunately, this is actually unusual because of, according to this feature of dynamic, the treatment jump up, and after that, the application of chemical therapy really have no positive result. And now let us see right side. There, the same size of chemical therapy and the same size of intensity therapy as applied, but we change only sequence before chemical therapy and after intensive therapy. As we see, the using of the same size of separate efforts give another result. Right picture show how the level of tumor jump down and its final result. Next slide. Oh, this presents another type of program, chemical therapy left, and combination of chemical therapy and intensive therapy right. Please, next slide. No, so let us fix the main idea. We present result of analysis of some conceptual, very simple one-dimensional model. And of course, the mathematical analysis of this process is based on the description attractor, Bayesian attraction, bifurcation, and really our example is very simple. Really is need to take into account more important detail. Of course, it's need to extend the dimension of model and preparing the more detailed bifurcation analysis. So I would like to finish my talk. Thank you for your consideration.
Thank you very much. I'm waiting for question. Okay, I'm asked one. How to fit your model to real data?
Oh, of course, the standard question really is the only conceptual model. And it's important to clarify what is the principal possibility, what is the principal qualitative situation can be arise in consideration of such type dynamics. Of course, it's need to adopt this model to more practical using, but it's not our today state. It's for future.
Thank you very much. Thank you. We have no question. In this situation, we go to the next presenter. Okay, and I ask for I present. Excuse me, are you here?
Yes.
Are you ready? You will present from your computer or from my?
From your computer.
Okay, I'm ready. Let's begin.
Yes. Okay.
Yeah.
Okay. Dear colleagues, hello. Let me bring to your attention the results of our study in the field of endovascular biometry. Next slide, please. We don't have any potential conflict of interest. Next slide, please. The relevance of research. In conditions of intensive technological development of healthcare, endovascular technology, in view of its effectiveness and safety, is a criterion of absolute choice in the treatment of patients with cardiovascular diseases. When performing endovascular procedures, technical difficulties associated with the use of catheters can arise, such as insufficient stiffness, patterns, and lack of reliable vertical stability of the catheters for manipulation with a guide wire, balloon, or vascular stents in the affected distal arterial segment. Unresolved endovascular care tasks may result in negative treatment outcomes consisting in the technical failure to restore blood flow through the target artery or development of an adverse outcome, a change in treatment strategy in favor of traditional surgery or conservative treatment. Next slide, please. The target of research: to study technical problems to providing of endovascular care and to develop technological solutions for its improvement of the basis of endovascular biometry. Next slide, please. The materials presented in this work are based on an analysis of the results of endovascular arterial catheterization for the diagnosis and treatment of patients with chronic low limb ischemia caused by atherosclerosis. The biometric features of blood vessels were studied. The definitions of weak and critical zones of arteries were given for the first time. An expert analysis of the results of endovascular treatment of patients with chronic low limb ischemia was performed, in which it was not possible to perform low limb revascularization according to the standard methods using a guide catheter, guide wire, and balloon catheter. The expert group of 5 interventional radiologists were created. The results were evaluated by the effectiveness of revascularization using the developed innovative technology from a system of catheters of various diameters and stiffness in comparison with the results of using standard endovascular technique. Next slide, please. Next slide. It has been established that technical difficulties in the catheterization of vessels create the prevalence of atherosclerotic lesions of the arteries and the limited technical capabilities of catheters and guide wires, which are manipulated under the conditions of increasing high friction with the vessel wall caused by tuberosity and atherosclerosis of arteries, the presence of weak and critical zones of the blood vessels, as well as a significant distance from the surgeon's hands to the area of medical manipulation, reaching 130 to 100 centimeters. The large diameter of the aorta or other blood vessel relative to the diameter of the catheters or conductor advanced alone creates the possibility of following the catheter and conductor inside the vessel into a loop and violated the manual management and functions. The division of vessels into branches is also the reason for the loop deformation of long flexible devices in the provision of endovascular assistance. Next slide, please. The steps of measuring the arterial channel from the puncture site in right brachial artery to the bifurcation of the abdominal aorta. The height of patient in this case is 179 centimeters. Using a sterile rule, we measured the segment of the guide catheter 100 centimeters long that remained outside when it reached of the abdominal aorta with the tip. Localization of the tip of the catheter and the bifurcation of the aorta level was confirmed by angiography. You can see in the picture. Next slide, please. It has been established that the average age of men in our study was 176 centimeters, women 169 centimeters. The average length of the arterial segments from the right brachial artery to the bifurcation of the abdominal aorta was 78 centimeters in men and 64 centimeters in women, which allows effective catheterization common iliac artery through the right brachial access using a catheter 100 centimeter long. Next slide, please. It has been established that brachial arterial access can be effectively used for angioplasty and stenting of the abdominal aorta, iliac arteries, and the common femoral artery. For retinalization of the superficial femoral, popliteal, and tibial arteries, we need catheterization of the common femoral artery or tibial arteries. Next slide, please. The results of endovascular care for patients with critical low limb ischemia and adherence to the algorithm and technique for performing arterial catheterization testified to the reliable safety of modern catheters and guides when using both femoral and brachial accesses. There were no complications associated with the critical areas of blood vessels, such as dissection of the vessel wall, separation of parts of atherosclerotic plaques with the tip of catheters, and embolization of the femoral, popliteal, or tibial arteries. The use of the proposed technology for vascular catheterization using a design of catheters of various modifications ensured the reliability of the system in blood vessels, resistance to the falling in weak zones, and contributed to the successful completion of the revascularization in 100% of cases in comparison with the results of applying the standard endovascular care technique. Next slide, please. In this slide, you can see the original bioengineering design of the 3 catheters of the various modifications, diameters and lengths for safety and effective advancement along the vascular channel under conditions of the stenotic atherosclerosis, tuberosity, and angulation of the arteries. Next slide, please. Next. Thank you. According to the results of the studies, it was found that the tactical planning of the endovascular procedures on the arteries of the lower extremities based on biometric indicators of the vascular bed, technical characteristics of medical devices, contributes to the correct choice of arteries for surgical access and tools for the effective and safe delivery of endovascular care. It should be emphasized the importance of the clinical and engineering competencies of interventional radiologists and cardiovascular surgeons in assessing the biometry of vessels and technical tools of devices. When working under stressful conditions with emergency interventions and the assessment of the state of the surgical field occurs and monitor screen. Thank you for your attention. Thank you, sir.
Thank you very much. We're waiting questions from chats or participants. I ask one question. You say that you try more than 1,000 interventions, and how you classify these results and successful and fail rate, or some problems? What's percentage of yes?
Okay, this is long way. This is long way. First time I have difficult with my work with patients, because I use different devices, different and I make good result with use different cassettes, like in slide. I think this use different cassettes together is a good chance for a good result. I look at every surgical operation every day. Thank you.
Okay, thank you very much for answer.
Thank you.
I'm going to the last presentation of this block.
Thank you.
Okay, determination of the. You sent me other presentation, yes?
I
This
is the right one. Can you show me the 8th slide, please? Yes, this is the right one.
Perfect. You will present from your PC or from my computer?
From your computer, please.
Okay. We are ready to the last presentation of this section. Please start. Not last, but last in this block before break. Yeah. Let's start. Please start.
Yes. Thank you very much for your attention. I'm Parnovskaya Anastasia, and I would like to present you research on determination of tissue properties based on modeling and electrical impedance registration. Please, next slide. Today, the impedance method is actively developing. Physical essence of this control method is that the system of 2 current and 2 measuring electrodes is placed on the surface of a research area. Current with the frequency of 50 to 100 kilohertz and amplitude from 1 to 10 milliampere is passed between current electrodes, and the resulting potential difference is recorded on measuring electrode. Values of electrical impedance carry information about electrical properties of tissue structures at the depth of current sensing. Number of studies have shown the bioimpedance signal can be used for bionic control for medical and multimedia devices such as prostheses, orthoses, exoskeletons, and surgical devices. Next slide, please. For biocontrol, electrode system is located in the projection area of muscles involved in performed action. Muscle contraction leads to change in electrical impedance that can be caused by changes of electrode system pressing force, fat skin layer thickness, change in muscle geometry, or change in resistivities of tissues. Next slide, please. Preliminary analysis shows that existing methods and approaches do not take into account number of important processes that should be considered in order to develop an impedance-based neuromuscular interface module. For its realization, it's necessary to solve a number of technical problems related to justification of optimal parameters and placement of electrode systems. To solve this problem, internal geometry of study area should be considered, and resistivities of its tissues should be indirectly determined, which our study is aimed at. As the object of the research, the upper limb was chosen, which is the most developed and effective part of our body. Next slide, please. "3D models of actual anatomy of 5 volunteers were created based on MRI images. These models were used in physical modeling based on finite element method. At the first stage, a series of cross-section MRI scans were contoured, and then these contours were connected using loft in Autodesk Inventor. Example of this model is shown in the slide. Physical models have some assumption. First, study does not take into account all the tissues of forearm area. Study only considered 3 of them: skin, fat, muscle, and bone. Second, all layers have isotropic properties with constant resistivities, and a model has a final longitudinal size. Next slide, please. To assess compilance of developed models with real data, measurement of electrode impedance were carried out. A signal was recorded in neutral position of wrist without performing any movement. Registration channels were evenly distributed around entire circumference of forearm. Flexible bracelet containing 8 tetrapolar electrode assemblies of 7 millimeter in diameter, and distance from each other was 10 millimeter each. This bracelet was located in upper third of forearm, and the impedance signal was recorded with the status A model, which technical characteristics are presented on this slide. Next slide, please. Resistivities of tissues vary depending on the type of tissue and from person to person. Values of resistivity presented in literature significantly differ from each other. Therefore, for development models, we used ranges of considered tissue resistivities, which are presented in the table on the slide. Potential distribution was obtained as the result of modeling, and then impedance value was calculated according to the formula shown below. Next slide, please. To determine electrical characteristics of tissue, simulated values was compared with real experimental data. For each value obtained during simulation by varying resistivities of tissues, relative error was calculated, and then for a channel, average error was determined. Then resistivities at which the minimum of average error was achieved were taken as the model parameters. Slide shows the data for one volunteer, and in the table above, you can see the resistivities at which the minimum average error was achieved. Next slide, please. The influence of changes in tissue resistivity on impedance has also been studied. Results show that variation of bone resistivity does not affect the impedance value, and skin fat layer most affects the impedance. It can be due to the fact that bone located far away from electrode assemblies, so current lines mostly pass through fat skin layer and muscle, which makes greatest contribution. Influence of changes in muscle layer resistivity on impedance was studied in more detail. You can see on the graph that by increasing muscle resistivity by 10%, it leads to impedance change by 1-2 ohm. And this value is actually really close to changes observed in impedance signal during movement. So in future studies, we will investigate the relationship between change in impedance and change in resistivity of muscle and skin fat layer during movement. Next slide, please. As a result of our research, physical models were developed and resistivity of tissues were determined for each volunteer. These models can be used to study mechanism of bioimpedance change during movements. Studies showed that variation of bone resistivity has small impact on impedance value, which correspond with our previous studies. So in future work, the effect of changes in bone resistivity will not be taken into account. Next slide, please. Thank you for your attention. I'm waiting for a question. We'll be glad to answer them.
Okay, we have no question in YouTube. For this reason, I ask one. I know that impedance tomography is very well studied field of research. A lot of work. These studies begin about 40 years ago, and currently about 10 or 12 articles about impedance tomography published every year. What's your novelty and what you try to do new in this field from your point of view?
Thank you for the question. Yes, this method is very good investigated, but still we can see lots of problem and lots of inaccuracies in bionic control realized by this method. And that's why we need improvement in this accuracy, and also all the studies that are carried out now are aimed at implement more anthropomorphic and comfortable using of bionic devices. For this reason, we are investigating parameters that could affect the accuracy of this control and signal registration. So on the third, I believe, slide, I have shown some parameters and effects that influence the bioimpedance signal, but all these effects are only mentioned to cause changes in impedance value, but not investigated in more detail. So our previous studies were aimed at investigating the influence of pressing force, and now we are investigating the effect of changing in the resistivities of tissue, which can occur.
Okay, and one more question, because you last presented in blog and we have free time now. Could you say me about your computation method? do you use finite element or boundary element method here?
Can you repeat, please, which methods you use?
Which method, which numerical method do you use?
The finite element method was used. There's no any particular reason for using this one, just physical modeling was done in COMSOL multiphysics environment, and it's the default method in here.
Okay, but here we can see the mesh for this simulation, and from my point of view, you need to adaptive refinement for points of electrode location.
Okay, I got you. This image show not the mesh of the physical modeling. It's just the contour that were done by our research group by hands, because any programs have lots of errors, and they are not very accurate. So these are contours made based on the MRI images. Then on the right picture, you can see the series of these contours. They just determine the fat skin layer, muscle, and bone. Then they were connected by using loft in the Autodesk Inventor, and only then this geometry of forearm was like a step model exported to the COMSOL multiphysics. And in COMSOL, we used the least finite mesh for modeling.
Thank you very much. Thank you. We have no other questions, and currently we have only 3 presentations before break. And for this reason, I say that we start long break until we have half hour until 2 p.m. 50 minutes. Okay, let's discuss. If you want, I can stay here and continue discussion. Vladimir, could you use break screen for this coffee break? And if you're interested in some discussion, we can stay here and discuss. Yes. Dural, maybe we start some discussion, no? Okay, in this case, I waiting for the next block of presentation. Thank you very much. It's very interesting results.
Мишель Фу. Мишель Фу. Мишель Фу. Мишель Фу.
Hello, everybody. We will continue soon. Dear presenter.
Hello.
Hello. I try to check presentation. First presentation is relaxation oscillation. Relaxation oscillation of the human body surface temperature after external impacts.
Да, я здесь на месте.
Perfect. Second, infrared silver halide fiber for medicine application.
Yes, I'm here.
Towards the realization and hollow core silver halide fiber for laser angioplasty.
It's mine report.
Perfect. And the last one, a novel method for humidification and ionization of indoor air.
Yeah, I'm here.
Perfect. We start after 2 minutes. We have two options. You can show presentation from your screen, or you can show presentation from my screen and you will speak only. You will speak only. What's option suitable for you, for all of you?
I prefer you to use your desktop.
Okay.
And me too.
So I prefer to use your screen as well.
Yes, my presentation from your PC.
Okay. We start our next block of presentation. Okay, and I open the first presentation, and if you're ready, you will start, and we will waiting for questions.
Okay, but I don't see anything. Dear Chairman, dear participants of the conference, let me introduce you the report, Relaxation Oscillations of the Human Body Surface Temperature After External Impacts. Next, please. Next, please. Next, please.
What slide do you want? Third?
Second.
Second?
This one.
I suppose happened a delay between our speech and video.
Okay. The human body is by and large a set of self-oscillating systems, regulation system with feedback. Each system has its own oscillation frequency. The level of blood flow in the skin affects the temperature of the surface of the human body. A change in temperature may indicate the effectiveness of a particular external influence and the process occurring in body in response to the impact. Next, please. Calculations of the frequencies of fluctuations in blood flow were performed, and the correspondence of the calculated frequency and mechanisms causing the fluctuations were found. The temperature fluctuations observed by us and external influences have frequencies much lower than those calculated for normal blood flow. The aim of this work is to calculate using the F approximation the possible periods of oscillations arising after exposure. Next, please. The time dependence of the surface temperature of the human body were measured after various external impacts, a cold test, and low-intensity optical irradiation. The surface temperature of the palm was measured with cooled infrared camera. Cold test. The hand was immersed in cold water for 1 minute. Then the hand was removed and the dynamics of the average temperature of the open palm was measured every minute. The inner part of the forearm of healthy volunteers was irradiated when exposed to low-intensity optical irradiation. Next, please. Next one, please. This slide shows the time dynamic of surface temperature at cold test, and you can see the fluctuations. Next, please. Here you can see fluctuations of the temperature with different periods at low intensity optical radiation for 20 minutes of observations. Next, please. Next. And this slide, on this slide, you can see fluctuations of the temperature with different periods at low intensity optical radiation for 40 minutes of observations. Next slide, please. Calculations of possible periods of observed fluctuations are made. The problem of finding periods is a solution to incorrect inverse problem. It is performed a Fourier analysis of the obtained time dependencies of temperature by F approximation method. Next, please. A new theory of constructing analytical approximations based on the method of linear integral representation of Strahov has been developed. Computer technologies for constructing the approximation design are divided in 3 stages. Next, please. At the first stage, elements of matrix A of linear algebraic equations are formed. At the second stage, a system of linear algebraic equations is solved based on a new theory of regularization of a system of linear algebraic equations. Next, please. The third stage is the restoration of the field and finding its transformants. It is important to emphasize that the method of integral representations allows you to filter out random noise in the input data, in our case, high-frequency oscillations. To solve our problem, the programs were modified for the one-dimensional case. As a result of the calculations, the spectral amplitudes of a possible vibration frequency were calculated. At this stage, we have received the results presented below. Next, please. The calculated periods of possible fluctuations that occur when restoring the palm temperature after a cold test are 4, 7 to 8, 10 to 11, 14, and 18 minutes. Next, please. For 6 minutes exposure, the following periods of temperature fluctuations during relaxation were obtained: 1.5, 3 to 4, 7, 11 to 13, and 18 minutes. Picture shows the possible periods of oscillation rising in response to 10 minutes radiation of the forum. Most likely they are 1.5 to 2, 4, 9, 12, 20, and 32 minutes. The calculated oscillation periods for 15 minutes exposure were 1.5 to 2, 4 to 5, 7 to 8, 14, 18, 20, 27 minutes. Next, please. The calculated periods for the selected 4 types of impacts are very similar. The spread of periods value can be caused by several factors. Among them are a small number of points for calculation using the F approximation, various types of influences, and as a consequence, differences in the response of the organism, and different total time of observations. The nature of fluctuations with periods of 1.5 to 2 minutes is as a result of endothelial activity. Fluctuations with period of 3 to 4 minutes are interpreted as adaptive activity of the organism. But we found oscillations with longer calculated periods, which can be observed in other works too, but ignored by the authors. The response time of the organism to temperature changes is 15 to 20 minutes. It is likely that the response time to external influences in the form of changes in surface temperature are also about 20 minutes and are determined by the work of the hypothalamus. Next, please. So we can conclude, seemingly, the fluctuations in the level of blood flow calculated in this work are associated with a regulatory process that start after the system leaves the equilibrium state and try to return it back. The feedback system can give them an oscillatory character. The F approximation method can be successfully used to determine periods of fluctuations in the temperature of the surface of the human body that occur when external influences are applied to it. Thank you for your attention.
So, thank you very much. We're waiting question from our colleague. If there are no questions, I ask one. Could you answer how to interpret this period in terms of human physiology? Why this fluctuation happened?
If you show the 14 slide, please. Yes. The the periods small one, smaller than 1 minute. It was calculated our authors and interpreted as a different activity which showed on the third slide. But here we can see the periods 1.5 to 2 means it is endothelial activity. The periods we calculated. We have calculated 3 to 4 minutes was interpreted as adaptive activity of organism at external influences, and we discovered more long periods, about 10 and 20 minutes, and we consider it as a work of feedback system, including hypothalamus work.
Okay, thank you for your answer. I go to the next presentation, and I need to notice that we have latency. This happened only on the last hour. Before we have no lag between speech and video, and I highly recommend you to use Zoom and comment your presentation from Zoom, not from YouTube, because on YouTube we have more latency between speech and video. Thank you for understanding of this. Okay, I open the next presentation. The next presenter, are you ready?
Yes, I'm ready.
Perfect. You will show from my PC or from your PC?
Your PC, please.
Okay. I'm ready. Let's start.
Well, good afternoon, dear conference participants. My name is Yezhakova Anastasia, and the topic of my talk is silver halide infrared fibers for medical applications. Next slide, please. The infrared spectral range is in demand for many fields of science and technology, including medicine, since a large number of organic compounds are absorbed in this range. In this regard, a large number of sources are developed for the infrared range, such as lasers, diodes, lamps. For example, some types of infrared lasers are shown on the slide. Receivers are manufacturing, for example, infrared cameras and detectors. Also, fiber channels for transmitting radiation based on different glasses and crystals are designed and implemented. Among optical fibers, the most promising are chalcogenide, fluoride, hollow, and polycrystalline fibers, since they have high optical properties and low losses. The last type of fibers presented has the widest transmission range from 2 to 30 or 20 micrometers, depending on the comparison and crystal system without absorption windows, which allows them to cover the entire mid-infrared range. Next slide, please. In the mid-infrared range from 2 to 15 micrometers, it absorbs a large amount of organic substances, since many groups of molecules have vibrations here. As can be seen from the figure on the slide, the CH, CO, and CC groups absorb most strongly in this range. In this regard, in the mid-infrared range, various biological tissues and substances can be investigated. As an example, the slide shows the absorption spectra of muscle tissue, fats, and linseed oil on the figure 1 and figure number 2. It is convention to use optical fibers to supply radiation to the test tissue. However, the fiber material must be non-hygroscopic and inert with respect to organic tissues and the environment. Next slide, please. The fibers used for infrared are shown on the slide. Among them, polycrystalline fibers of the argentum chloride, argentum bromide system, hollow and fluoride fibers are safe for tissue. However, as can be seen from the figures, the transmission range of polycrystalline fibers, argentum chloride, argentum bromide system, is much larger in comparison with other types of fiber, and the optical loss is small. In addition, polycrystalline fibers are flexible. With increasing bending radius, the optical loss in such fiber is negligible. Thus, for medical applications, polycrystalline fibers are the most promising. Next slide, please. Polycrystalline fibers of various systems are developed at the Ural Federal University at the Scientific Laboratory of Fiber Technology and Photonics. In this laboratory, a full production cycle is carried out from the synthesis of a high purity raw material to growing crystals and manufacturing optical products. We have developed and grown crystals of various systems, such as argentum chloride, argentum bromide, thallium iodide, argentum bromide, and thallium bromide iodide systems, and are now developing new optical crystals of the argentum bromide, argentum iodide system using the Bridgman method. Among them, crystals of the argentum chloride, argentum bromide, and argentum bromide, argentum iodide systems, which are non-toxic, non-hygroscopic, and flexible, are applicable for medicine, which are safe for organic tissues. Crystals of this system are transparent in the range from 0.5 to 35 micrometers and from 0.5 to 30 micrometers respectively. Stepindex's fibers are made of crystals by extrusion from a turned blank. The extrusion diagrams is shown on the slide. This technology allows the manufacture of fibers with a diameter of up to 90 micrometers, which is a record low value in the world. Fibers based on them are transparent from 2 to 20 microns, depending on the comparison and system. Examples of fiber transmission spectra are shown on the slide. Next slide, please. Next slide. Next slide, please.
You want 7th slide or 6?
6, please.
Okay, 6th slide already here.
I'm sorry. In addition to step index fibers, photonic crystal fibers can be made from crystals. We have developed a 7-stage extrusion process, which allows us to obtain fibers with special properties: a large mode field, single mode operation, selective properties, and others. The slide shows a photo of the obtained fiber with a hexagonal structure of the inserts and a comparison of photonic structure fiber and a step index fiber. The process of manufacturing photonic crystal fibers is time-consuming and expensive, and therefore we used computer simulation with which we designed the photonic structures. Next slide. Number 7. Thanks. Modeling was performed by the finite element method. As input data, we specified the optical properties of fiber elements, the characteristics of transmitted radiation, the geometric parameters, and boundary properties. To approximate the model to real conditions, a perfectly matched layer was created around the fiber. As a simulation result, structures with a low mode operation were selected that ensure a large mode field and high energy transfer. The slide shows the model selected for manufacturing for a wavelength of 10.6 micrometers. It's a wavelength of CO2 laser with a mode field diameter of 100 micrometers. Photonic crystal fibers are intended for direct exposure to infrared radiation on biological tissues or fluids. Next slide. Next slide, please. Thanks. To study the properties of tissues and liquids, a fiber probe was developed that connects to spectrometers and operates on the principle of attenuation total reflection. The probe has a sensitive element, which is made of polycrystalline fiber in a loop form or sapphire in a cone or prism form. The first type is used for non-aggressive liquids, gases, and bulk solids. The second type for aggressive environments and solids. The slide shows the background spectrum of a probe with a loop and a photo of a silver halide-based fiber probe with a removable sensing elements. Next slide. Using a probe with a loop, we studied the spectra of acetone shown on the slide. The study was conducted with a single and double loop. As can be seen from the figure, the absorption peaks of acetone correspond to known values at a wavelength of 5.8, 7.3, and 8.1 micrometers. Moreover, with an increase in the loops number, the spectrum becomes more clear and precise. The probe is connected to a spectrometer using a specially designed device shown on the slide. Next slide, please. Thus, polycrystalline fibers have a high transmission in a wide range, which allows them to study the spectral properties of organic substances and affect tissue by transmitting radiation to the desired area. The fibers are flexible, non-hygroscopic, so they are safe for the body. Thank you for your attention, and I'm ready to answer your questions.
Okay, questions, please. Chat in YouTube is empty. Maybe some ask questions here. Okay, in this case, I want to ask one question. How this technology can be used in biomedical application? What kind of device or what kind of treatment required in this type of fiber optics?
For medical applications, today using attenuation total reflection when probe used with spectrometer. The obtained spectrum give different information about molecules and about different вещества.
You mean this device is helpful for some biochemistry devices also, or for intervention? I don't understand clearly. It's for device which test some probes, or you mean this device is a catheter which?
I understand. This device one second. Give information about different areas of people's care or body liquid and other. Не обязательно проба. Sorry.
Okay. Okay, thank you very much. Thank you for your answer. It's very interesting.
Oh, please switch on your microphone.
Sorry. I'm ready for the next presentation. Do you want to show from my computer or from your computer?
From your.
From my, yes?
Yeah. Thank you.
Okay, I'm ready. Let's start.
Okay, thank you so much. Good afternoon. I'm Elena Korsakova. I'm a junior researcher at the Scientific Laboratory of Fiber Technologies and Photonics at the Ural Federal University. And today I would like to present to you my research devoted to the development of silver halide fibers for laser angioplasty. Next slide, please. I'm going to talk about the fundamentals of laser angioplasty technique, about the current situation in this field, about some improvements which we propose, and I'm going to discuss the preliminary results of our investigations. Next slide, please. Atherosclerosis is one of the most common diseases and one of the major causes of mortality worldwide. There are various treatment methods for atherosclerosis, including angioplasty. Conventional angioplasty techniques are complicated and not applicable in many cases, unfortunately. Therefore, the development of improved minimally invasive methods is crucial. The aim of the given study is to develop advanced silver halide fibers for more effective and safe laser angioplasty. Next slide, please. Laser angioplasty is based on the selective absorption of infrared radiation by cholesterol esters, which are the main components of atherosclerotic plaques, approximately at 5.75 micrometers. Next slide, please. In a few words, this method implies passing a catheter with optical fiber through the entire length of a vessel to deliver infrared laser radiation, and as a result of interaction between this radiation and atherosclerotic plaque, to vaporize all of them along the vessel wall. It was revealed that during this procedure, it is crucial to maintain the precise wavelength because even the slight shift of wavelength may cause the damage of the vessel wall. Next slide, please. We work in collaboration with a research group from the Tuvilov State Optical Institute. They developed a tunable mid-infrared laser, which provides the radiation wavelength of 5.75 micrometers with a bandwidth of about 10 nanometers, which is necessary for precise ablation in angioplasty. Next slide, please. The use of advanced channels for delivering laser radiation may facilitate the implementation of this angioplasty. From our point of view, all solid silver halide fiber is a good choice for this, especially taking into account our recent advances, because for the first time ever, the fabricated silver halide single layer fibers with an extra small diameter of about 100 micrometers. They are very flexible, highly transparent at this wavelength, and possess low bending losses. Additionally, their end faces may be profiled to form a lens in order to increase the precision of ablation. Next slide, please. However, there is the issue of damaging all solid silver halide fibers. For moderate ablation effects, one can use quite low power density values, but in some cases, peak power density is higher than the laser-induced damage threshold of all solid silver halide fibers, as seen in the graph. Next slide, please. That is why we decided to focus our attention on hollow core fibers, which can deliver high power laser radiation, and a hollow core Bragg fiber working at a wavelength of 10.6 micrometers was taken as a prototype. It is also worth mentioning that the closest analogs, metal hollow core fibers operating at 5.75 micrometers, are virtually inflexible. Next slide, please. Our research group has already succeeded in the fabrication of fine silver halide tube intermediates. The vacuum deposition of thin silver halide layers on the inner surface of these tubes has been chosen as a preferred technique for gaining the fiber in question. Based on previous investigations, we plan to develop the regimes of the vacuum deposition, which must include the following parameters: vacuum volume, temperature profile, deposition rate, and film structure and thickness. Next slide, please. Thus, we will perform the full production cycle for obtaining from obtaining raw materials to manufacturing end products. However, we need to start with some more steps and I would say it's one of the main steps of the fiber development process. I mean the numerical simulations of fiber structure. Next slide, please. To simulate our fiber, we utilized a commercially available program, COMSOL Multiphysics, based on finite element method. We conducted the analysis of mode field distribution along the fiber cross-section. The outer fiber diameter was chosen to be 700 micrometers based on available dyes, and its core was 300 micrometers in diameter for the convenience of coupling laser radiation into the fiber. We varied the thickness of Bragg rings along with the compositions of fiber elements and consequently their refractive indices. Next slide, please. Thus, we considered more than 100 models with the refractive index increment of 0.01 for each of two alternating layers for achieving the conditions of Bragg diffraction, and ultimately for creating an optimal model which allows maintaining a single mode operation at the wavelength of 5.75 micrometers with minimal possible optical losses while the maximal mode field area. Here you can see the selection of the optimal number of Bragg structure layers. Next slide, please. We found an optimal structure which possesses quite a large effective mode area and allows transmitting radiation with low optical losses. In this structure, the thickness of rings with a high refractive index is 5 micrometers, and the thickness of rings with a lower refractive index is 2 micrometers. Due to attained single mode operation and the increased level of laser-induced damage threshold, along with preserved flexibility, non-toxicity, and non-hygroscopicity, these fibers may be applied for highly precise and effective laser angioplasty and may significantly advance its in vivo application. Next slide, please. Well, thank you for your attention. I will be glad to answer your questions.
Okay, I'm ask one questions for you. You say that this technology will be used for laser angioplasty.
Yes.
Could you perform some tests with laser angioplasty or use these fibers in clinical practice or experiments maybe?
Well, there are some in vitro experiments which were presented on the maybe 4th. Could you please return to the 4th slide? Oh, 5th. The next, yeah. Here you can see atherosclerotic aorta. It was in vitro experiment. It means that these vessels were taken from the body, but here you can see in action this laser angioplasty, because the atherosclerotic plaque was damaged on the contrary of the normal wall, because this precise wavelength doesn't affect normal aorta. Okay, thank you.
Thank you very much. It's very interesting. We have no other questions, and for this reason, I'm going to the following presentation.
Thank you so much.
Okay, who is the presenter?
I'm here. My name is Wali.
Okay, you will share a screen, or you will tell and I show from my screen?
Yeah, I prefer to use your screen, please, if possible.
Of course. We are ready?
Yeah. Hello, everyone. My presentation titles is a novel method for humidification and ionization of indoor air. Next, please. So here you see in the slide outline, please. Next, please. Nowadays, air conditioning is essential for human convenience during hot waves. It provides sleep quality and reduces the risk of health issues such as dehydration and asthma. In the cold season, when apartment is heated around the clock, the air in room becomes excessively dry. Low humidity mainly affects the child's body, contributing to the development of respiratory disease and cause general malaise. Next, please. The child's body is subject to state of drowsiness and rapid tiredness. The health of adults also deteriorates when they are always in room with low humidity, which not only affect their performance and well-being, but can also contribute to the penetration of pathogenic bacteria into their bodies. People who suffer from allergies, the symptoms of this disease get worsened due to an increase of the content of dry dust in the dry air. Next, please. So in this slide, we can see the optimal parameters of air humidity. It's believed that the optimal air humidity should be in the range of 40–60%. However, for children, it's desirable to have greater humidity parameters up to 70%. That's explained by the fact that the baby's nasal passages are very narrow and the airspeed is greater through them than in adults. Therefore, moisture from the mucous membrane evaporate much faster. Next slide, please. Various types of humidifiers in different studies are purposed to increase air humidity. However, still a lot of them have one common essential drawback. They don't allow evenly distribute humidified air in the room. This is the main problem of these humidifiers. To overcome this drawback, we developed a method to humidify indoor air using a jet of air rings saturated with water or vapor. Also, we maintain optimal humidity by maintaining the optimal concentration of negative and positive ions in the air. The level of ionization is considered optimal. The number of ions in 1 cubic centimeters of air. Positive light ions 5,000 and negative ions 6,000. Unipolarity coefficient 1.2 or 0.8 in this range. Extremely acceptable deviation from the optimal level positive light ions 10,000 and 10.5,000 and negative this same. Next slide, please. So some words about air ionization. Artificial ionization of air bring it closer to the state of outside air, whose molecules are exposed to ionizing natural factors, resulting in the formation of negative and positive ions. The degree of ionization of the atmosphere is characterized by number of ions in 1 cubic centimeters of air, which usually contain about 1,000 light ions, the number of which decrease up to 200 in winter and rise to 3,000 in summer. An increased concentration of negative ions is observed in forests near waterfalls, mountains, and water bodies. Hygienists and physiologists have no definite opinion about the influence of the sign of charged ions on the nature of physiological shifts in the human body. Therefore, it's advisable to adhere to values corresponding to the parameters of fresh outdoor air during artificial ionization. Next, please. So there are many design of ionizer, the action of which is based on various principles. Here we note an ionizer with needles combined with a shape of air rings. It can produce ions of various signs depending on the connection of the positive or negative pole of the high voltage source. To ensure the well-being of people, the noise from the working humidifier must not exceed the value corresponding to the normal physiological perception of person. Next, please. So the main problem is the conventional air conditioning methods can produce noise. House games or virus that cause multiple problems in respiratory and hearing system for children and adults. The low air humidity affects the performance of the human and also contributes to the penetration of pathogenic bacteria into the body. Next, please. So the goal of this work is to develop a novel solution to reduce noise and get better control of the humidity of indoor air condition and make it with additional option which consists of ionization of the air. Next, please. So methodology of this work, the purposed solution is based on using ultrasonic and infra-low frequencies to ensure complete noiselessness, guarantee well distribution of humidity, and ensure efficient condition indoor places. The highest efficiency occurs when the device operates at the frequency of its isolation of the shaper membrane. Next, please. So in this slide, we see the developed device. As you see, it consists of a reservoir with water. The water from reservoir 7 through tube 6 enters the membrane 4, covering it with a layer of this liquid. The membrane is excited by the ultrasonic frequency generator, number 11, as a result of which the liquid breaks up into particles with a diameter up to 5 micrometer, which rise in the form of fog into the upper part of housing. The infra-low frequency generator, number 10, vibrates the shaper membrane, which sucks through the whole 13 when moving to the left content. I mean fog. It sucks the fog, and in this case, the particle in contact with bottom 11 and needles 14, which are under high voltage, acquire a charge, and the sign of this charge depends on the potential sign at the terminal 15. Next, please. Next. Once again, next, please. 14 slide. Yeah. So the movement of the membrane to the right, accompanied by the ejection of rings 9 from the shaper, which at low initial speed up to 1 meter per second, can travel a fairly large distance up to 4 meters. The reverse course of the membrane is accompanied by the absorption or sucking of fog into the chamber along the periphery of the whole 13. A steady stream of the contents of the housing is sucked into the cavity of the former. By varying the initial speed of the ring and the direction its movement, it's possible to deliver the rings to any reachable location in the room. Next, please. So, as I said before, that the performance of shaper or former of these rings can be controlled by changing the amplitude or the frequency of the generator. So, for example, 16 hertz can produce 16 rings per 1 second. If we want to increase this frequency, we get 50 or 10 rings per 1 second. And in this slide, you can see the formula of this performance. Next one, please. Yeah, if we add to the system some sensors like air humidity sensor, air ionization sensor, and temperature sensor, we can make it automated system for humidification and ionization. So the control device get information from all these sensors and send some commands to low frequency generator, which is responsible for exciting the operation of the shaper. A high voltage unit. It's responsible for ionization. Ultrasound generator is responsible for making water or transfer water from liquid to gas. Next, please. So the movement of air rings with a low initial speed will gently affect open area of human skin, without causing unpleasant tactile sensation. At the same time, more uniform humidity is achieved through the room. So we get distributed humidity in the whole of place. The use of purposed methodology should ensure decreasing noise to the minimum degree and also well distribution for the humidity. This approach makes it possible to use this device even during sleep. The highest efficiency occurs when the device operates at the frequency of its oscillation of the shaper membrane. The required value of unipolarity coefficient is achieved by changing the sign of charge on the needles of a humidification and ionization device. Thank you for your attention.
Thank you for your presentation. I invite question from our colleagues.
May I ask you a question?
Thank you.
Okay. So you've mentioned the advantages of your development in comparison to conventional devices for indoor humidification, but what about the price?
Okay, the price, we didn't calculate this moment, but I think it can be made from cheap parts. It's not so difficult to develop such a device, but by time we didn't make any calculation for the economic calculation.
Okay, thank you.
Thank you very much. Currently, we pass this time, and currently we have free discussion in program, and I really don't know what to do because I try to raise discussion on each break, but it's not working. Maybe we go to Russian language if most part of our people here speak in Russian, or we can speak on English or sometimes, because I suppose from my point of view, the main advantages of conference, it's possibility to speak with other scientists and possibility to share our opinions. And for this reason, I suppose maybe we can speak for on free topics. Maybe we can speak about conference or something. Друзья, давайте на русском поговорим. Мне сказали, что в части конференции, которая про безопасность, они уже успели поссориться с самого начала и долго кого-то распекают.
Окей, why not? Давайте перейдем на русский. Можно обсудить что-нибудь?
Я увидел, что здесь появились Вот, честно говоря, как председатель секции, я сам занимаюсь вычислительными задачами, то есть я очень плохо понимаю в физических устройствах. Может быть, вот как-то прокомментируется, кто лучше понимает про оптические кабеля, про различные девайсы, что они думают об общем уровне работ, о их применимости реальные, вот про ионизаторы, например, что-то типа такого рассказать.
Конечно, трудно комментировать по одной лишь презентации, что действительно на самом деле, в каком объеме было сделано. Ну, общее впечатление вполне благоприятное. Презентация выполнена на достаточно хорошем уровне.
А вот у кого были доклады про оптические кабеля? Вот у меня такое ощущение, что там на самом деле часть, связанная с биологическими науками, очень маленькая получилась по сравнению с тем, сколько рассказано про обработку и подготовку, собственно, оборудования.
Оптические кабеля. Ну, у меня было оптическое волокно.
Это получается как кабель. Окей, я понял, как это по-русски. Оптическое волокно. Здорово. А у нас все остальные коллеги, они все англичане, наверное. Или все стесняются?
Ну, на самом деле у меня мое исследование очень тесно связано с биомедицинским применением, поскольку непосредственно на человеческих сосудах планируется использовать, вводить внутрь сосуда эндоскоп, ну, катетер, можно сказать, или канюлю с волокном, и уже используя лазерный луч вот этой точной длины 5,75 микрометров, воздействовать на атеросклеротическую бляшку, тем самым вызывать ее абляцию, она будет плавиться, испаряться, и в дальнейшем просвет сосуда будет восстановлен в результате этого воздействия. То есть бляшка уйдет посредством обычных биологических механизмов, вот эти облированные ткани будут, они рассосутся, можно сказать, и просвет сосуда, самое главное в этой методике лечения атеросклероза, будет восстановлен. На самом деле сейчас используется достаточно сложный процесс, баллонная ангиопластика, то есть внутрь сосуда вводится катетер, в котором есть стенд. Посредством очень хитрого механизма этот стенд расширяется, восстанавливая просвет сосуда, но бляшка никуда не девается. Эта бляшка начинает выпирать, как бы сказать, сосуд, начинает действовать на близлежащие ткани. Извиняюсь, наверное, я заняла время много сказать.
Ну, мне вот интересно вопрос такой, вот во всем этом докладе я не очень понял, какая жесткость этого кабеля получается. То есть, в моем представлении, катетеры, у них две проблемы. Первое, что если они сломаются внутри, то они не должны причинить существенный вред, то есть внутреннее содержание не должно быть сильно токсичным. А второй момент – это жесткость катетера, потому что если он недостаточно мягкий, то его достаточно сложно куда-то протолкнуть.
В том и дело, что сейчас предлагаемые решения, они не очень применимы к реальной жизни, потому что используется полое волокно на основе металлической матрицы, и внутри аргентум йод покрытие напыляется. То есть это не гибкий совершенно инструмент, и он используется поэтому, как вы видели, только в инвитро исследованиях. Но мы имеем уникальную возможность использовать галганит-серебряные волокна. Они очень пластичные, очень гибкие. И самое хорошее по сравнению с ближайшими аналогами халькогенидными волокнами, они не токсичные, и они не гигроскопичные. То есть вот эта вот совокупность уникальных свойств галганит-серебряных волокон позволяет их использовать эффективно в тонких эндоскопах с размерами френчей. Ну, это система измерения диаметра катетеров и различных эндоскопов. То есть там 5-9 френчей – это применимо для сосудов среднего диаметра. То есть это главные сосуды, в которых располагаются атеросклеротические бляшки. И посредством использования полимерных катетеров для того, чтобы защитить наше волокно, потому что, в принципе, планируется использовать его не одноразово, и нужно его от контаминации защитить. То есть с боковых поверхностей мы защищаем полимерным катетером, а с торцевой поверхности мы будем использовать призму алмазную для того, чтобы направить, извиняюсь, слышно меня, нет? А для того, чтобы
конечно.
направить излучение на боковые поверхности, на стенки сосуда, а не в русло кровяное.
Спасибо. Коллеги, а может быть, кто-то еще прокомментирует доклады? Вот, или кто-то, наверное, был на предыдущих секциях, ну, не на предыдущих блоках с часу до двух, например. Вообще, какое общее представление о секции, которой вот я председатель? Что вы думаете о докладах? Какие вам понравились сильнее, какие меньше? Никого не было. Я вижу, что здесь еще Анастасия Юзаева, ой, не Юзаева, наверное.
Южакова, наверное, все-таки. Южакова,
Да,
да, здравствуйте.
Южакова. Да, напомните, пожалуйста, о чем у вас доклад был?
Мой доклад был перед докладом Елены, тоже по галогенит-серебряным волокнам.
Понятно. Ну, то есть вы вместе из УРФУ.
Да. Ну, я могу добавить пару слов вот еще к использованию галогенит-серебряных волокон, к их преимуществам. Очень много, в принципе, разрабатывается различных зондов на основе волокон, не только там инфракрасных, но и для других диапазонов и спектра, и на других материалах. И вот преимущество конкретно наших волокон еще заключается в том, что их легко стерилизовать. Как бы очень важный аспект для медицины.
Да, это понятно, потому что для того, чтобы пройти лицензирование в Европе или в США, обязательно нужно, чтобы дезинфектант не разрушал материал, которым он дезинфицирует. А
по поводу докладов, я, к сожалению, слушала не все, но вот с 10 часов буквально доклада 4, наверное, помимо нашего вот этого вот блока прослушала. Доклады на самом деле очень интересные, но так как они были во многом связаны с медициной, а мы все-таки занимаемся больше оптикой, поэтому трудно их объективно воспринять, но тем не менее, в принципе, очень хорошая, полезная конференция. Спасибо вам.
Вам спасибо, что участвуете. Коллеги,
вот такой еще вопрос можно спросить?
Да.
Будут ли доступны доклады, записи докладов после?
Они сейчас доступны, трансляция идет на YouTube.
Я понимаю, но, к сожалению, я конкретно вынуждена работать, имея рядышком с собой 2 детей, и просто не было физически такой возможности послушать все доклады. После конференции будут ли выложены записи?
Да, я думаю, что там настройка сделана в YouTube, что он сохраняет трансляцию, она должна появиться в виде этой через полчаса уже. Плюс, если вы видите, у вас должно быть нарисовано такое облачко, где-то сверху экрана зума, идет еще дополнительная запись в облако. Так что
спасибо
записи
большое.
будут. Единственный вопрос, кто будет их редактировать, и мы думаем, что мы не будем редактировать, потому что у нас нет ресурсов и желания. Но вообще мне уже несколько человек написало из других городов, что они не могут тоже быть, но готовы слушать конференцию постфактум. Вот.
Окей.
Я вот вижу еще нескольких людей, например, Роман Голощапов, Аксенов, вы вот тоже несколько...
Да, слушаю вас.
Да, скажи, вот я на самом деле не очень понял, может быть, как-то... Я просто не стал как чайр задавать второй раз вопрос. Мне все-таки очень интересно, вот вы используете катетеры в большом количестве интервенций, так?
При каждой интервенции используем катетеры. Да.
Но вот у меня вот какое представление о катетерах? То есть я сам занимаюсь электрофизиологией, там обычно говорят, что вот на больших выборках пациентов там столько-то осложнений такого рода, столько-то такого рода, столько-то такого рода. Вот у вас есть эта классификация, что происходит с пациентами и какие вообще выходы из такого количества?
Ну, собственно, эта работа, она родилась из проблем использования катетера внутри сосудистого русла, я честно говоря, нет, она не просто из-за того, что мы катетеры используем, а именно с теми сложностями, даже не столько с осложнениями, а в первую очередь осложнений не очень много при эндоваскулярных вмешательствах, а именно сложности выполнения манипуляций на значительном удалении от твоей руки, от руки оператора, которые связаны с проблемами и извитостью сосудов, и атеросклеротическим сужением, и с повышением силы трения, с большим удалением от места пункции артерии. Вот. И, собственно, почему возникла идея делать вот такую конструкцию, это, опять же, в литературе, честно говоря, практически нигде об этом не пишется, и пишутся данные о том, что такое-то количество осложнений возникает, но не описывается, какое количество интервенций, которые начались, не заканчивается успехом, то есть не выполняется. И вот это одна была задача. И вторая задача, как решить все-таки проблему, чтобы каждая интервенция, она заканчивалась результативно, результатом положительным. Вот. Поэтому вот это, конечно, это длительный путь прошел. Я уже об этом говорил, что это достаточно длительный путь к тому, чтобы из того, что ты имеешь, потому что я же не инженер, который изготавливает эти катетеры, проводники. Я пользователь. Но из того, что есть у нас в руках, у интервенционистов, можно сделать такую конструкцию, сделать ее, с одной стороны, очень гибкую, с другой стороны, безопасную для того, чтобы продвигать по извитым атеросклеротически измененным артериям, ну, или венам, вот, и в то же время не повреждать стенку, потому что, ну, вы должны, как физик, понимать, что если мы, скажем, в трубку, которая имеет вид синусоиды, будем засовывать какую-то трубку меньшего диаметра, то она будет воздействовать как раз на углы, вот, на сгибы, там, где... И атеросклеротически измененные сосуды, они имеют другую эластичность стенки. Причем стенка – это одно, а бляшка, которая внутри находится, мы ее можем просто рассекать катетером. Так вот, в итоге это касается в первую очередь заболеваний нижних конечностей, и здесь я привожу пример, потому что с сердцем там немножко все по-другому и гораздо более легче, на мой взгляд, с технической точки зрения. А вот с конечностями...
Там коронарное русло есть, там есть...
Нет. Коронарное русло, да, но там артерии, они все малого диаметра, то есть это 2-4,5-5 миллиметров и все. А здесь мы должны преодолеть артерии большого диаметра и достигнуть артерий, воздействие лечебное должно быть на артерии малого диаметра, дистальное русло и так далее. И чтобы туда добраться через достаточно длительный путь, мы должны сконструировать такую конструкцию из системы катетеров, что вот и в работе описано, чтобы и была вертикальная устойчивость, когда мы выполняем манипуляцию по прохождению полностью закрытой артерии, чтобы катетер не отталкивался обратно, чтобы сила бляшки, сила окклюзии была меньше вертикальной устойчивости катетера. Вот, это раз. И второе, самое главное, чтобы эта система была безопасной. Чтобы она не рассекалась, чтобы она не срезала бляшку. Потому что, допустим, нам нужен там катетер 8 French, это достаточно широкий. Так вот, мы его пока будем продвигать, если мы его будем продвигать по проводнику диаметром 35 тысячных дюйма, то мы можем кончиком катетера широкого просто посрезать бляшки и вызвать дистальную эмболизацию. Поэтому, чтобы безопасно, скажем, его было продвигать, нужно внутрь этого катетера установить либо специальный буш, который убирает вот этот зазор между проводником и кончиком катетера, либо систему катетеров, чтобы безопасно, как бы один по-другому двигаем. Вот так, как рельсы. Такие внутренние рельсы создаем. Вот смысл в этом работы.
А вот можно прокомментировать, например, вот в этой секции были доклады про подведение оптических кабелей к бляшкам. Насколько вы думаете, это реалистично довести до клинического применения и насколько это может быть транслировано в клиническую практику?
Так это используется, скажем, оптический когерентный томограф или датчик для внутрисосудистого ультразвука. Это широко используется, применяется для визуализации внутрисосудистой. Это такие же гибкие структуры, но мы их заводим, уже заводим эти кабели по катетерам. То есть сначала мы в устье устанавливаем, в устье артерии устанавливаем катетер специальный. Ну, будем его называть гайд-катетер, проводниковый катетер. Вот. А уже внутрь по этому проводниковому катетеру заводим гибкий диффузор, так скажем, кабель, для того, чтобы выполнить уже исследования внутри сосудов, ну, в частности, коронарных сосудов и так далее. Это сейчас очень широко, вернее, не сейчас, это уже давным-давно применяется достаточно широко, с 90-х годов. И внутрисосудистый ультразвук, чуть позже оптическая когерентная томография.
То есть вы проводите исследования томографические, изучаете внутреннюю структуру стенки сосудов, так?
Внутреннюю структуру стенки сосудов. Изучаем, что происходит с бляшкой, насколько она повреждена или нет, тромбогенна или не тромбогенна.
Это у вас клинические испытания уже?
Нет, это уже не клинические испытания, это рутинная практика.
Ага. А что же нового у вас?
Вот новое, нет, это был дополнительный вопрос модератора по поводу кабелей. А в этой работе я именно представляю, вот, как нужно поступить в сложных ситуациях. То есть группа больных была такая, у которых традиционными способами было либо опасно манипулировать. То есть что такое традиционно? Это использование катетера, проводника. Дальше уже баллона. А часто очень не представляется возможным безопасно завести катетер туда, куда необходимо. Длина большая, это почти метр, иногда гораздо больше, это для проводникового катетера. А чтобы реканализировать, восстановить просвет закрытой артерии атеросклерозом, этот участок находится еще дальше, он находится на расстоянии 1,5, даже до 2 метров. И вот чтобы сделать катетерную конструкцию более устойчивой, потому что мы, когда проходим проводником, катетер будет отталкиваться обратно.
Ну, а на самом деле, да. Можно, извините, я вас прерву, да. Какой метод лечения используется? Вот это все диагностика, а затем...
Нет, это только касается в первую очередь лечения. Я в своей практике, вот я сердечно-сосудистый хирург, я оперирую и открытым способом, и, ну, скажем, имею в руках технологию для традиционной хирургии и для рентгеноэндоваскулярной. Но открытым способом я фактически людей не оперирую. То есть это всего лишь 10% пациентов. 90% это больные, которым выполняется рентгеноэндоваскулярная операция.
Ну, то есть им баллоны ставят?
Нет, баллонная пластика, стентирование. Но прежде чем подойти к этому этапу, к баллонной пластике и стентированию, нужно артерию восстановить ее просвет. Восстановить просвет. И вот это самое главное, бывает сложно. Потому что я могу сказать, что иногда прикладываешь всю силу, которая есть в твоем теле и в твоей руке, для того, чтобы гидрофильным проводником пройти хроническую окклюзию артерии. То есть плотность бляшек такая, что она равносильна камню, как гранит. И, конечно, чтобы пройти такой плотности окклюзию, нужна очень надежная система катетеров. Просто когда катетер один, он тонкостенный, да, он имеет оплетку в своей структуре, в структуре стенки, но он все равно из-за того, что он тонкостенный, он гибкий, он переламывается, он может под прямым углом полностью сложиться от напряжения. Поэтому, когда мы внутрь катетера устанавливаем еще катетеры более малого диаметра, вот идеальные результаты были получены, когда 3 катетера один в другом были. Вот при жестких окклюзиях это было идеально, и решался вопрос. Но в целом, на сегодняшний день, вот используя в руках фактически то, что уже производители сделали, просто это нужно научиться этим пользоваться, делать конструкции во время операции. В каждой операции индивидуально можно сделать рентгеноваскулярным способом фактически любую операцию. То есть помочь пациенту малоинвазивно и тем самым качество жизни пациента поддерживать на высоком уровне при оказании помощи. Потому что при таких многоуровневых, скажем, поражениях, это тяжелая категория больных с многоуровневым поражением артерий. Конечно, открытые операции, они, во-первых, сопровождаются высоким риском, они очень длительные, продолжающиеся и 3, и 4, и 5, и 6 часов. Вот. Я просто сам через это прошел и вот подошел уже несколько лет назад именно к позиции, что нужно все-таки стараться малоинвазивно пациентов лечить. И в практике это применяю достаточно, на мой взгляд, успешно.
А можно спросить вас, скажите, пожалуйста, какие бы идеально были размеры для самого маленького катетера, то есть 3-го, который внутри всех остальных?
Ну вот самый малый катетер у меня либо 5, либо 4 френч.
Это сколько на миллиметр? Там на
1,8. На 1,8.
1,8 миллиметра, да?
Ну, в общем, 6 френч – это 1,8 миллиметра, соответственно, 5 френч еще меньше.
А если бы это было 100 микрометров, и он был бы очень прочный в плане того, что гибкий, с одной стороны, а с другой стороны, он не переламывался бы?
Это, ну, то есть это фактически проволока.
Да. Что
нельзя так использовать. Почему? Потому что мы просто где-то в каком-то сегменте рассечем атеросклеротическую бляшку и вызовем несквозное повреждение артерии, диссекцию, которую потом нужно будет в этом сегменте либо баллоном долго держать, прижимать, либо прижимать стентом для того, чтобы не стало. Потому что ведь артериальное русло нужно понимать, что это давление, и давление высокое достаточно. Иногда такое бывает, что манипулируешь на артерии, все равно ты думаешь о том, что будет с пациентом, что будет с теми сегментами в ближайшем послеоперационном периоде, когда ты инструменты удалишь, потому что током крови, давлением крови, такие работы есть, они описаны, может происходить диссекция, через несколько лет может образовываться аневризма в этом месте и так далее. Поэтому и мы, проводники, стараемся все-таки не сами продвигать. Вот проводники, вы понимаете, жесткая структура, это провод, это струна. Просто какие-то более жесткие, какие-то менее жесткие, и они есть там, наиболее часто это 35 тысячных дюйма, 14 тысяч дюйма, это вот самые такие рабочие размеры проводников, которые мы используем. Мы их стараемся не просто в сосудистом русле продвигать, а именно продвигать внутри катетеров пластиковых.
Ну, а как вы справляетесь с бляшками, которым не подходит лечение стентированием или установка баллонов?
Но я вам сейчас могу сказать, что нет бляшек, которым не подходит стентирование. Есть...
Я слышала, под коленками нельзя использовать.
Есть поражения, где нежелательно использовать стентирование. Вот. То, что касается можно или нельзя, для этого есть клинические рекомендации, и в подколенной области просто нежелательно использовать стенты, потому что они рано или поздно все равно слабость металла, она есть, и какой бы ни был гибкий стенд, и даже сейчас позиционируют специальный стенд только для подколенных артерий, и стентируем подколенные артерии, и дистальные стентируем. Но здесь другое. Если после баллонной ангиопластики остается диссекция, то есть не сквозное повреждение стенки сосуда, рассечение, скажем, да? Интимы. Рассечение интимы, рассечение бляшки атеросклеротической, то нужно чем-то прижимать, потому что сохраняется риск послеоперационного тромбоза.
Ага.
Поэтому
то есть, вот исходя из ваших слов, я так понимаю, что к абляции вы скептически относитесь?
Нет, к абляции чего? Абляция проводящих путей сердца – это одно, а вы имеете в виду лазерное прожигание в бляшке дырки? Ну, почему? Наверное, это имеет место быть. Я просто не прибегал к этой технологии никогда в своей практике, потому что я решаю вопрос теми инструментами, которые есть у меня под рукой.
То есть
более
коммерчески доступных нет абляционных систем?
Нет, лазерная реканализация, есть такая технология, и есть оборудование, которое применяется в практике. Я об этом оборудовании знаю. Я просто о другом говорю, что стараюсь в своей практике использовать более безопасные методики, потому что лазер все-таки мы вслепую идем и можем дырку прожечь в стенке артерии. Когда ты работаешь гидрофильным проводником внутри артерии, вероятность перфорации, она невысокая. Ну, вот так. Поэтому я не против.
Просто мое исследование, извините, мое исследование связано как раз с использованием очень точной длины волны, которая не прожигает стенку сосуда. 5,75 микрометров – это та длина волны, которая сохраняет стенку сосуда и селективно действует только на жиры бляшки.
Я понял. Но бляшка – это не всегда жиры.
Я понимаю, что там есть эта фиброзная шапка, что там есть еще, что она находится прям в стенке в каком-то этом сосуде, да? В каком-то резервуаре прям.
Бляшка?
Да.
Бляшка – это вот, ну, грубо говоря, это такой нарост внутри сосуда, сложную имеет химическую структуру, вот, но я вам не хочу ничего против сказать против лазерной реканализации. Это только мое мнение, и я обхожусь теми инструментами, которые есть у меня. Причем, ну, в случаях, приближающихся к 100%. Если мне не удается сделать эндоваскулярно, я просто перейду на открытый этап и сделаю это открыто.
Просто я не специалист, как вы понимаете, в области медицины, и мне интересно узнать из первых рук, так сказать, такую информацию. Вот мне очень интересно было бы с вами еще в дальнейшем повзаимодействовать.
С удовольствием.
Вы можете написать контакты друг другу в чат, например, можно сделать это приватно. А вообще, я думаю, что, наверное, можно съездить в город, где врач находится, на какую-нибудь конференцию. Вот мы обычно так делаем в нашей группе.
А из какого вы города?
Я из Москвы.
Очень приятно. Я из Екатеринбурга. Ну,
классный город.
Было бы очень приятно, да, как-то вместе, совместно посотрудничать.
Ну, пожалуйста, можно в чате, я могу так продиктовать телефон, он не секретный.
Давайте.
Я не рекомендую использовать приватные данные публично, потому что у нас стрим идет на этот, и это останется на всю жизнь. Запишите, пожалуйста, друг другу в чат сейчас, это более безопасный способ.
Да, благодарю. Вот. Ну, приятно, спасибо большое за конференцию, и интересные доклады просто не всегда удается в течение дня послушать, работа идет, но это отличное решение, мне понравилось, спасибо.
А скажите, пожалуйста, откуда вы узнали про нашу конференцию? Нам бы хотелось больше даже клинических докладов, это всегда вызывает интерес.
У меня есть консультант, он также является автором доклада и публикации. Дмитрий Иванович Кича, руководитель кафедры организации здравоохранения. Вот информация появилась, и вместе подготовили этот доклад. И с Ольгой Викторовной Шараповой, это главный врач городской больницы московской.
Ага.
То есть это через кафедру, да.
Вот у вас кафедра называется «Организация здравоохранения». Дело в том, что у нас в УРФУ, в Уральском федеральном университете запускаются программы по обучению этой медицинской биохимии, медицинской биофизики и медицинской кибернетики. Вот, собственно, две программы уже работают, то есть там учатся студенты с понятным выходом, а медицинская кибернетика будет запускаться в этом году. Я вот и руководитель этой программы. Может быть, мы с вами как-то сможем тоже взаимодействовать, и вы проконсультируете, что востребовано в клинике и прочее. То есть, насколько я понимаю, сейчас по этой специальности готовят врачей-статистиков, как они раньше назывались. И, может быть, у вас какое-то видение по этому вопросу будет, если у вас кафедра так называется?
Ну, конечно, можем взаимодействовать и общаться, естественно. Никаких преград для этого нет.
Спасибо вам.
Да, спасибо вам за организацию такую хорошую.
Ну, это заслуга, скорее, организационного комитета, а не моя. Коллеги, давайте, у нас еще осталось 13 минут до начала следующей секции, которая будет последней. Может быть, еще какие-то вопросы будут по этим. Вот я заметил, что здесь уже почти нет людей, кто занимался вычислительными науками и приложениями вычислений в этом. Может, все-таки кто-то остался и помнит, что было на первых двух секциях, или кто-то посмотрел стрим постфактум. И вот я, например, знаю, что Гульназ Зунимова должна была представлять доклад в первом этом. Артем Малахов. Может быть, кто-нибудь еще присутствует здесь? Владимир, а ты мне помогаешь. Может быть, ты как-то прокомментируешь что-нибудь?
Ну, как? Все доклады интересные были, я считаю. Конкретно, какой доклад мне понравился больше всего, сейчас, может, найду. По-моему, он из 3-й секции был.
У тебя есть спойлеры к тому, что будет в будущем конференции, потому что у тебя есть все доклады. Если кто не понял, Владимир это подстраховывает меня технически, то есть если у нас все упадет, то задача Владимира оставаться и листать слайды хоть как-нибудь, чтобы конференция продолжалась. Шоу must go on. Вот, расскажи нам, что тебе вот понравилось за сегодняшний день. У нас остался последний блок лекций. Мы скоро к нему придем.
Мне понравился тот доклад, где был про браслет, где с томографией было. Я не помню, в каком он был блоке.
Потому что очень близко к твоей тематике, потому что ты понимаешь в электрофизиологии, и ты понимаешь, как это работает. Наверное, так, да?
Наверное, да.
Кстати, на этом докладе было больше всего человек в YouTube. То есть вот когда он там очень хорошо сделана презентация, действительно. Ну, я высказал свое мнение, наверное, в вопросе, то, что возникает вопрос, что там со стороны научной новизны, потому что эта тема очень-очень хорошо изученная. Но презентация была сделана потрясающая, и пиковый онлайн по YouTube как раз пришелся на этот доклад. Вот. А кто-нибудь застал его? Наверное, нет, да? Ладно. Коллеги, я предлагаю тогда до конца отдохнуть. У нас еще 15 минут до начала следующего блока. Я думаю, что мы после блока тоже останемся поговорить на русском языке или на английском языке, потому что я чувствую, что нужно поднимать дискуссию. Все-таки достаточно сложно общаться вот так вот по Zoom с незнакомыми людьми. Когда вживую люди общаются на кофе-брейк, конечно, намного приятнее. Но, тем не менее, вот сейчас мир так устроен, что Zoom-конференция — это единственная возможность как-то что-то делать. Ладно, я пока отключу тогда этот и буду готовиться к следующей секции, хотя бы научусь читать названия докладов. Значит, начало будет в 16:00.
Спасибо большое.
Спасибо вам. DRL, I'm search for the following author, the following presenter. Excuse me, I search Artem Malakhov. Are you here? I'm waiting authors of the last presentation. DRL, I'm waiting authors. We have one minute before start. Vladimir, could you hear me?
Yes, I hear you.
Okay, DRL. Who is presenter of the use of electrical impedance research method to assess the heart response to drug treatment?
Oh, the study is mine.
Hello.
Hello.
Second, development of a novel technique for delivery of powered drugs into lungs as aerosols of variable dispersion. Елена Лебединская, are you here? Okay. And the last, a method of deep delivery of drugs into the biological tissue.
Yes, I'm here. Lebedinskaya is here.
Okay. Okay. Two presentation. Елена Лебединская in Елена Лебединская and
then Olga Lebedinskaya.
Perfect. And also I search for missing presentation, architectural and algorithmic model for intelligent clinical decision support system. Indira Uvaleva, are you here? Okay. In any case, we should start, and I've opened the share my screen. Are you ready for how you prefer to present your work? I can show my screen and you will speak, or you can share your screen and show on your computer. Artem Malakhov.
That's mine. As you wish. Do you hear?
I can hear you. It's the voices. You have a poor connection.
Do you hear me?
Very bad.
Hello.
Yes.
Oh, I have. And now maybe now. Do you hear me? Can I talk about our work?
Excuse me. You have a very poor connection.
Hello.
Vladimir, could you check voice?
I try
check
to
connection.
get better internet. I have a good connection. I see you and hear you.
Okay, perfect. Let's start. From. Okay.
Let's start.
If you want, yes, of course.
Okay. Hello. My name is Artem Malakov. I am from Bauman Moscow Technical University. And I present you our work with using electrical impedance research method. We used this method to drug treatment, impedance methods a lot of years, and now we have some methods which can be used in heart disease, in diagnostic of heart diseases. And this work was prepared, and we try to understand how heart can respond to the drug treatment, and we try not only with patients with heart disease, we work with patients with oncology. And the next slide, please. And please, next slide. We know that many drugs which can be used in treatment, oncology treatment, can be very cardiotoxic. So in our investigation, we work with patients with lymphomas. Two patients, in this presentation, I will show the results on the patients with non-Hodgkin's lymphomas and Hodgkin's lymphomas. The next slide, please. So in these investigations, we used multi-channel electroimpedance system REL32, which was developed in our department of biomedical engineering in our university, and to understand how heart activity is can change. We use three precordial electrode systems. One of these electrode systems is needed to understand how work ventricles, one for arterioles, and one to understand a local blood filling of the soft tissues. The next one, please. In this method, we can estimate heart activity phase structure. So in this figure, you can see two periods which can describe activity of the atrial, and three periods for the ventricles. These periods can show how show parameters which can describe electrical and mechanical activity of the atrials and ventricles. The next one. So we used three precordial electrical impedance channels and one ECG channel. All investigations was carried out under the same conditions. So the results will be was closed. So the next one, in this investigation, we work and I show you the results on the 3 patients, 2 patients with non-Hodgkin lymphoma and 1 with Hodgkin lymphoma. All staged first the day before the start of the treatment course, and the second stage measurement after 3-4 days after the beginning of the course. Each measurement has a number of recordings and a number of cardio cycles. So we that allowed us to calculate the average values and their stability. Next one, please. Next one, please. Next one slide, please. Hello. Next one. Thank you. The first patient with Hodgkin lymphoma, he had BCOP 14 polychemotherapy course. All courses had 2 main drugs. The first one, doxorubicin, and another prednisone. So the first patient, all parameters was changed after the using of cardiotoxic drugs. So the most significant changes occurred in the values of periods of which about atrial and isovolumetric contractivity. Isovolumetric contraction. And you can see that stability of the isovolumetric contraction has very big change. The next patient, the next one, please. Next slide. Next patient with non-Hodgkin lymphoma and R-CHOP polychemotherapy course. In this situation, we had the next effect, that very big decrease of atrial projection phase. So this phase is indicate that how fast can tissues mechanical how fast mechanical activation of tissues can be start after electrical after the starting of electrical impulse. So in this variant we see also that isovolumetric contraction was more has the stability of this parameter was worse, got worse. And the next slide, please. Patient third patient with non-Hodgkin lymphoma and RCNOP polychemotherapy course. So there we see some change, and and all patients have the same change in as follows in parameters APEP. So this parameter it's preparation atrials for mechanical contraction, and another change, most significant change in isovolumetric contraction. So The next one, please. These changes can show that biophysical parameters of the tissues is changed. So these changes can be used to understand how heart react to the drug treatment, and in future we can create methodology to understand effectiveness of the drug treatment and treatment courses. So now that's all. Thank you.
Thank you very much. We have time for questions. Maybe one questions. Okay. In this case, I ask my questions. What frequency do you use for impedance measurements, and do you try to different frequencies and some approach for combining it?
Thank you. We used probing frequency 100 kilohertz. So this is the main frequency which we use. We don't try to use more another frequency 80 kilohertz. Don't make our signals better in theory. So I know that, for example, a system from Droger, which investigations to understand how lung can be better while used some treatment. So this system use some frequencies, but they use these methods to find main frequency, parameters of the signal, noise parameters of the signal. But in our electrical solutions, in our systems, we go by another way, and we try to get lower noises in the electrical solutions, so we can use the main frequency, only one main frequency, and it's enough for us. So this one. So
okay, thank you very much. We have no time for other questions, and
okay, thank you.
I'm ask about the following presentation. Are you ready? Could you share your screen, or you will comment slides from my computer?
Yes, I am Lebedinskaya Elena. We want to tell us about development of a novel technique for delivery of power drugs into lungs as aerosols or variable dispersion. Our work is from Department of Biomedical and Electronic System and Technologies, Vladimir State University, and from Clinical Air Throat Nose, named after Professor Aleneva from CTPM. The treatment, next please. The treatment of severe lung diseases. The treatment of severe lung diseases is quite a serious problem due to the fact that there is a certain difficulties in delivering the drugs directly into the lungs for direct expose to the lung tissue. Basically, such treatment is carried out by injection or inhalation, which in some cases doesn't provide the desired therapeutic effect and does not lead to a quick recovery. Although the usual inhalation as a drug delivery technique has a number of advantages, it doesn't significantly improve to the patient's state, which can get worse even during inflammation processes in the lungs. Then the most part of the inhalated drug doesn't enter the lungs. Next, please. The difficulty in delivering provided drugs. It is generally acceptation that a low inspiration rate is a serious obstacle to powder inhalation, since the powder passively enters the respiratory tract with a slow flow or inhaled air, which negatively affect the pulmonary disposition of the drug. In this case, pulmonary disposition also depends on the diameter of the inhalated particles. Next. The purpose of the work is the development of a new technology for the delivery of the medical powder preparation to the lungs through inhalation, where the liquid components is the delivery vehicle. Next. It is the picture of the device for powder drug inhalation. A device for inhalation of powder drugs that implements the specialized method contains a source 1. It is on the picture 1. Of a drug 2, consisting of powder particles coated with a volatile liquid 3, connected through the hole of a tube 4, one end of which is connected on an air, south, and 5. The other is placed in the patient's mouth. A tube 4 is led with an air of a certain temperature into which the drug 2 is sent from the south 1 through the hole 3 in the form of drops of a certain size. When they enters the air, the droplets begin to evaporate along their entire path from the whole tree to the destination of the respiratory tract of the patient. Please, next, and then next. Next, and then next. Precise drops. Larger liquid particles precipitate in the upper respiratory tract. Other that they have significantly evaporated and decrease in the diameter precipitate after the indicated particles is a more distant place of the respiratory tract. The last smallest particles fall into the lungs. In this case, the remaining fluid is removed from the lungs in the natural way by subsequent exhalation. The particles of the drug powder deposit of the surface of the lung tissue. Note that drugs evaporation droplets of the drug are cold, which fall over the destination with a acceptable temperature. For example, it is considered that hot solution with a temperature above 40 degrees suppress the function of the ciliated epithelium. Next. Temperature change. If necessary, it is possible to change the air temperature and or temperature of the component during the treatment procedure, which will ensure the corresponding change of the dispersion of the aerosol and its precipitation sedimentation in different zones of the respiratory tract. The droplet size can also transformed by changing the length or the part of their movement. The longer the path or the move times is given for evaporation, and the smaller the diameter of the droplets of the drug components becomes. In addition, it is possible to change the evaporation time by the patient's breath. The longer the patient's breathing, the longer the droplets evaporate. Thus, their diameter becomes smaller and they penetrate the respiratory organs of the patient. It seems for us that this method can help to treat the lung problems during the COVID-19, but we don't know what drug can help to do this. We have the method, but have no drugs. Then second, please. The children aerosol therapy. It is the next variant of aerosol therapy. There exist various rehabilitation methods of nasal cavity and upper respiratory tract. And an advantage of inhalation therapy over other methods is that it can be used to realize the upper respiratory tract from the pathological concepts, as well as to bring drugs to the mucosal membranes of the respiratory tract. This increases the intensity of the drug absorption in the body, increased disposition of the submucosal layer of the upper respiratory tract, and created the high concentration of this medicine in the lesion. The high effectiveness of aerosol therapy allows us to recommend it for widespread use in medical practice, especially as complex treatment. For children of preschool and primary school age, inhalation treatment is associated with a number of difficulties, primarily due to the increased emotional and motor accessibility, which makes it practically impossible to use a breathing mask connecting tube for treating procedure, which the child is afraid begin to act up and cry. Please, next. You can see children physical emotional stress during using the compressor inhaler. And then next. And above this, we decide to remote aerosol therapy method. In this regard, the clinic throat and nose named after Professor Aleneva, together with Vladimir State University, developed an aerosol treatment method based on the remote effect a patient by aerosol drug stream formed from a sequence vortex rings. Such rings having a very low initial speed, about 1 meter a second, can noiselessly more keeping their shape up to 5 meters to the nasolabial trigger area placed on the patient face, bounded by the mouth, nasolabial folds, and nose. These vortex rings create in this zone therapeutic air-medical mixture for subsequent inhalation. Thanks for this, the child behaves calmly without realizing that he is taking a medical procedure that can be carried out with this method ever for sleeping patient. To coordinate the work of inhalation apparatus with the patient, it is necessary to know the distance that the vortex ring can travel, depending on its initial velocity. So, in this paper, a mathematical model of a movement of an aerosol ring was developed. Please, next. The device for formation of vortex aerosol rings. Therapeutic aerosol leaving the whole of the device forming a jet, connected into vortex rings, moving into zone of the nasal trigger of the child head. The child inhales the air-medical mixture in the course of the breathing with the usual familiar action through the nose or mouth. Please, next. Let an aerosol link with the velocity UO be formed by the section OO, to which the surrounding air is sect with a velocity VO. In the process of movement, the ring mixed with the air, forming a mixture, is in a figure. In the required to find the relationship between the pressure P in selection X and contain pressure PO in selection OO, and also determine the distance in which the ring will mix with an air to the specific property volume of the medium supporting the aerosol per unit volume space in this section. Mixing the aerosol with occurs during its movement. The aerosol penetrates in the surrounding volume of the mixture by molecular diffusion and turbulent pulsations. The mixing penetration velocity depends on the size of the contact surface S of unmixed aerosol volumes and surrounding mixture of the difference of condensation of the indicated volumes and the mixture of the intensity of mass exchange with the environment. Based on the law convention of mass, we can write. And last, results and discussions. The lung and respiratory diseases are changing the health due to the difficulty of delivering a sufficient amount of drug, particularly directly of the lung or respiratory system. Therefore, new technology was developed in work for the delivery of the medical powder preparation to the lungs by inhalation, where the liquid components is the delivery vehicle. The considered technique is based on the use of warm air or a changing the temperature of the drug during inhalation, which always you are very rate of evaporation of drops medicine and delivering powder particles in the different parts of the respiratory tract. By changing the temperature of the air, the drug, you can vary a rate of the evaporation of the droplets, the latter, and deliver powder particles of different parts of the respiratory tract. In increase the droplet speed of movement due the decrease of the mass during the evaporation process make it possible to increase pulmonary disposition even at a low patient inspiration rate. And silent inhalation with the help of the vortex rings does not cause anxiously a small child during the treatment process. That's all.
Thank you very much. We are waiting for questions. Okay, I ask one. Could you, does this model, could you predict size of part of drugs which reach target with this method? I mean,
we spoke about two methods. One method, it is for adult, for using different temperature for drugs to put it into the lungs, in the different part of the lungs, larger parts in the high part in the and small with a high temperature in the lower part. And the second method is for child, to make rings of inhalation and to put and the child can't understand that they make a medical procedure because they don't see an apparatus with these rings. And
Thank you.
About what method you want to ask me?
I want to ask about both, but we have no time. I'm sorry. I'm sorry for this. It's very interesting. Thank you for clarification of this this difference between three methods.
Thank you. Bye.
We have time after this block to discuss a little bit more maybe.
Thank you.
The next presentation. I'm waiting for presenter. Are you here? Olga Lebedinskaya, are you here?
Yes, I'm here.
Yes. Are you ready?
I'm ready. Thank you.
I'm sorry, we have problem with screen share.
I can. I can begin. Can I begin?
So sorry, could you see my screen?
Can I begin? Yes?
Yes, yes.
Yes. Good day, dear friends. Nowadays, such methods as, next slide, please. Nowadays, such methods as electrophoresis and phonophoresis are used to penetrate a substance into human biological tissue. Electrophoresis promotes deeper penetration of a drug substance through the skin with the help of an electric current flowing through the electrodes applied to the decided location. During electrophoresis, the injected drug deeply penetrates about 2-3 centimeters, while only 3 to 10% of this drug. Phonophoresis, on another side, is the introduction of a medicinal substance using ultrasounds, which is essentially carried out by the same basic mechanisms as electrophoresis. The depth of drug penetration during phonophoresis is much smaller and amount to 2-6 millimeters. However, phonophoresis has great functionality because, for example, it can be used for ultrasound physiotherapy in the tubular cavities of the human body. Despite its essentiality and obvious advantages, these methods have disadvantages. During electrophoresis, the following current can change the structure of the composition of the drug substance due to the galvanic effect. In addition, it cannot be used if the patient has a heart rhythm disturbance. And phonophoresis has contraindications for diseases of the cardiovascular system. In addition, these methods only have a local effect and don't allow the treatment of relatively large or specially spaces pain areas, such as knee joints or both legs. Please, the next slide. One part, methods. The proposed method for delivering a drug deep into biological tissue based on the phenomenon of electroosmosis, which means the movement of fluid through capillaries or a porous septum during application an external electric field. In this case, the velocity of the electroosmotic flow is proportional to the magnitude of the external field and surface charge density, and inversely proportional to the viscosity of the liquid and the thickness of the diffuse layer. The phenomenon of electroosmosis is also used in physiological experiments to inject substances through a micromolecular route into the individual cell. Next slide, please. To eliminate these drawbacks, The authors of this paper developed a method that allows the injection of the drug into the tissue in a vast area without exposure to electric current. This expands the range of used drugs and reduces the time of medical procedures. Next slide, please. A device that implements this method is shown in the figure 1 below. It contains electrodes 1 and 2, respectively places about the under section 4, covered with the medicine 3, so that field lines 5 of the field pass through the section. The electrodes are connected to the positive and negative terminals of a power source. In this case, a hidden element 6 can be placed into electrode 1. Next, please. Through the use of power source, an electric potential of about 40 volt is formed as the electrodes 1, 2, and thereby an electric field is created between them with power lines 5, directed from the positive electrode 1 to the negative 2. A layer of liquid therapeutic substance 3 is applied to the diseased area 4, which is placed between the electrodes 1 and 2, perpendicular to the power lines 5 of the created electric field, while the biological tissue and the drug 3 should not touch the electrodes. Under the influence of an electric field, the therapeutic substance 3 begins to penetrate deep into the tissue. The penetration rate will be proportional to the magnitude of the electric field and inversely proportional to viscosity of the liquid. Please, next slide. We have some formulas what can show model of this method, and about 17 formulas, and will be results and discussion. We take the dynamic viscosity of the liquid equal to the viscosity of water at a temperature of 20 degrees of Celsius. Its value is 1.002 MPa, as the length of the capillary skin thickness is in 1 millimeter and the pressure difference of its beginning and end is 10.13 and 20.26 Pa. Next slide, please. Substituting these values in the formula 17, we obtain the dependence of the volume of liquid penetrating is through 1 centimeter of skin, or the radius of its pores at various value delta P, P1 minus P2, as shown in figure 2. The dependence of the volume Q of the liquid flowing through the skin from the radius R of its pores. Next, please. It can be seen from the figure 2 that the dependence of the volume of liquid penetrating through the pores is close to quadratic. This is because with an increase in the radius of the pores, their number per unit area decreases. Therefore, the dependence of the volume of liquid penetrating through the pores will be proportional to the square of the radius of the pores. It can be seen from the figure that even with small pore sizes, significant penetration of water through the pores of the skin will occur. Next slide, please. In conclusion, the proposed method of drug delivery deep into biological tissue is based on the phenomenon of electroosmosis, which is the movement of the fluid through capillaries or a porous septum when external electric field is applied. Unlike methods such as electrophoresis and phonophoresis, the proposed approach allows the treatment of relatively large and spatially spaced pain areas, for example, knee joints of both legs. In this paper, a mathematical model is developed that allows you to determine the necessary parameters that described the penetration of a drug into biological tissue. The lack of direct contact of the electrodes with biological tissue allows the simultaneous treatment of large areas of diseased areas that are spaced in space. The rejection of the use of currents for the delivery of drugs into the biological tissue allows you to expand the range of drugs used. The volume of fluid penetrating through the skin pore is proportional to the fourth degree of its radius. Water-insoluble drugs can be used in the form of colloidal solutions. Thank you for your attention. That's all.
Okay, we are waiting for question.
Yes.
No questions here, because for this reason I ask one for you. I see studies with histology slices, and I want to ask you about statistics. Do you try to calculate some statistical properties of difference which you see on these histological slices?
It is the first part of experimental. Therefore, there in this report will be only mathematics model, and after will be experiments with the skin, with another tissues of the body. It will be next part. Thank you.
Thank you. Thank you. Okay. Currently we have.
Okay. That's all. Thank you very much. Goodbye.
And the last presentation.
Thank you.
And the last presentation. This presentation was missed from first block. Are you here?
Yes. Yes.
Okay, you will present this. Perfect.
Thank you.
Okay, we what's most suitable for you? This I'm sorry. At the end of the day, it's very difficult to work full day. Please, could you share it from your PC, or you can comment from my screen?
Your screen is okay.
Okay, perfect.
Thank you.
Okay, we are ready.
we have this difficult situation that my name is Gulnaz Zunimova. I am a PhD of Indira Uvalieva. Is it okay?
Okay.
Thank you. So we are presenting the research on the theme architectural and algorithmic model for intelligent clinical decision support system. The next slide, please. So this report includes the following items: architecture's review of the existing clinical decision support systems. The next is conceptual model of clinical decision support system, and the algorithmic model for intelligent clinical decision support system. Talking about the purpose of the research. The next slide, please. One of the directions of development of information technologies is the development and application of information medical systems and their integration into a single information space. To solve these problems, it is necessary to develop decision support systems that contribute to improving the efficiency of medical and diagnostic business processes, which can find their place in existing integrated systems. And the paper describes architecture's review of the existing clinical decision support systems and conceptual model of clinical decision support system. This research also proposes the development of architectural model for an intelligent system for supporting clinical decision made on the example of diagnosing blood diseases that are based on the integration of 3 architectural templates: object-oriented, 3-tier, and componential architectural model. The next slide, please. Decision support system was created as a result of the merger of management information systems and the database management systems. The decision support system is designed to support multi-criteria decisions in a complex information environment. The decision support system solves 2 main problems: choosing the best solution from a variety of possible solutions, it is optimization, and the ordering of possible solutions by preference, it's ranking. And figure 1 shows the standard scheme of the decision support system. So, and we propose an improved generalized architecture of the modern decision support system, which is shown in figure 2. And the knowledge base in number of interpretations can be composite and consists of a general knowledge base, a system knowledge base, and an applied knowledge base. A necessary element of the proposed structure of the decision support system is the validator, which checks and clears the data found by the DSB or entered by the user, possibly with the participation of experts. And the individual architectures of decision support systems for clinical decisions have the specifics as they relate to more narrow area of medicine. For example, the clinical DSS, which is decision support system, looks in accordance with figure 1. World Health Organization approved DSS architecture is health level 7. It is the 7th level of medical document management, which standards for exchange, management, and integration of electronic medical information. And
next slide, or this slide?
Conceptual model, yes. Conceptual model, next slide, please. conceptual model of clinical decision support system. Thank you. The conceptual model of the clinical decision support system in the diagnosis of blood diseases can be presented in the form. This model units RAM model, knowledge-based model, user interface model, logical output procedure model, the solution interpretation model, model for filling and checking the knowledge base. The next slide, please. Structure of information technology. Structure, the general structural model of information technology diagnosis of blood diseases is presented in this slide. As you see, the RAM model is used for storing data of differential diagnostics of clinical and hematological syndromes entered by users and the results of differential diagnostics of clinical and hematological syndromes. The next slide, please. For the decision support system for the diagnosis of blood diseases, there is a knowledge representation model that integrates the frame structure and the fuzzy production model. A frame has a certain internal structure consisting of a set of elements called slots, which are also named. Slots are followed by locations where data representing the current slot values are being placed. A frame model of knowledge representation is used to describe groups of indicators of clinical and hematological syndromes and to describe the cause and effect relationships linking diagnosis with indicators of clinical and hematological syndromes. And knowledge providing model can be shown as in the following model, shown in this slide. And about the next slide, frame-based architectural model of system. The frame class is a top-level frame for representing a collection of sample frames. Protoframe is used to describe the object of diagnosis of diseases of the blood, which is invested with protopam diagnosis, protopam groups of diagnosis, protopam individual characteristics, protopam groups of signs, and protopam complexes of symptoms for diagnosis. A frame has a certain internal structure consisting of a set of elements called slots. The fuzzy production rule is defined as model, shown in this slide. This model units fuzzy production rule, the linguistic variable of the diagnosis of clinical and hematological syndromes for the conclusion of the fuzzy production rule, the weight of the fuzzy production rule. Next slide, please. To create a fuzzy production knowledge base, it is necessary to design the general structure of the set of fuzzy production rules, which is presented in this slide, in this table. We can go on if you have looked through.
Please clearly say the next slide and I switch.
Okay. As an example of the rules in the complex of science for the diagnosis of iron deficiency anemia can be defined as follows. The figure shows a fragment of the frame structure of the knowledge base. The next slide, please. To fill in the knowledge base, the expert identifies the relationship of the main groups of blood diseases with signs, indicators of clinical and hematological syndromes, groups of signs for diagnosis, etc. in accordance with the algorithm in figure 1 on this slide. Next, it is necessary to determine the rules for diagnosing clinical and hematological syndromes with input and output parameters based on the fuzzy logic method. Table shows the values of the membership function intervals. And the technology proposed in the dissertation research to support decision-making in the diagnosis of blood diseases and the knowledge-based verification system so are designed to identify contradictions. This verification system analyzes expert data using the algorithm shown in this figure. In the previous slide I'm talking about. Yes, so this verification system analyzes expert data using the algorithms shown in this figure. Thank you. So concluding this research work, in this research described architectural and algorithmic model for an intelligent system for supporting clinical decision made on the example of diagnosing blood diseases. Model is based on the integration of 3 architectural templates: object-oriented, 3-tier, and componential architectural model. The proposed technology for decision support in the diagnosis of blood diseases is described in the form of a conceptual model: knowledge base, user interface, logical inference procedure, mechanism for explaining the decision, and model knowledge acquisition. Thank you. And this research proposes the development of architectural model for an intelligent system for supporting clinical decision made on the example of diagnosing blood diseases that are based on the integration of 3 architectural templates. As I'm just defining: object-oriented, 3-tier, and componential architectural model. Thank you.
Thank you very much. Yes,
have some questions, please. Could you send it to Indira Valiyeva's email?
In any case, I need to ask one question for this. I'm interested about this system. Sorry, we have raised hand. Some people want to ask questions.
Yeah, can I ask one question, please?
Yes, of course, yes.
The presenter introduced very good work about intelligent system for
my professor. This is my professor's work.
Okay, my question is, what is which kind of intelligent technology you use in this work? I didn't say any intelligence part in this system. Maybe I didn't understand or something like that. The intelligent part of your system, can you tell me which part is intelligent?
Which parts of intelligent system?
Yeah.
It proposes development of architectural model for an intelligent system. So I can find what intelligent system she has used.
Okay, thank you.
I can ask her and tip to the chat if you want. After 3 minutes or 2 minutes.
Okay. during the discussion maybe.
Okay, we finish our last block of in second session, and currently we can speak on different topics on English or in Russian, like you want. Let's discuss something. I will glad to see your opinion about conference and other topics.
Хотелось бы сказать спасибо всем докладчикам за выступление, очень было интересно. И спасибо председателю за проведение.
У меня вопрос к Елене Лебединской. Можно вы с нами? Елена, вы с нами? Видимо, нет. Просто по их... Ну, я просто скажу тогда в звуке по теме вдыхаемых аэрозолей. В прошлом году, либо на прошлом USBEREIT, либо на Сибириконе была статья про моделирование как раз этого процесса. И я думаю, что это очень близко к тому, чем занимаются, вот, собственно, эта группа, которая представляла нам результаты. И, может быть, если бы они знали друг друга, то они смогли взаимодействовать. Вот. Я думаю, что если это кого-то заинтересует, надо просто поднять старый USBEREIT или старый Сибирикон. Сибирикон был в этом году, USBEREIT был в прошлом году. И посмотреть работы по вдыхаемым аэрозолям. Я думаю, что это может кому-то сильно помочь.
На конференции Сибирикон?
Да, Сибирикон же был в прошлом. Ну, вот совсем недавно был.
Это не очередная такая же конференция была, как у вас в УРФУ, нет?
Ну, Сибирикон он больше, но реже проводится. Сибирикон он сибирский, сейчас он проводится в 3 городах и проводится либо раз в 2 года, либо в 3, я точно не знаю. Но там объем просто подных работ больше, и там немножко по-другому устроены секции, у него другой фокус.
Интересно, потому что лично я участвовал и на первой конференции USBEREIT, и второй, и вот сейчас очередная третья. И уровень организации очень сильно вырос. Я вас поздравляю с этим. Спасибо вам большое.
Спасибо. Спасибо вам большое. Я, правда, не организатор, но я передам всем, что да, уровень организации.
Ну, Василий Борисов, я знаю.
Да, это его заслуга. Коллеги, у меня вот вопрос по поводу работы, которая была последняя представлена. То есть, насколько я понимаю, это же база данных, по сути, которая ставится внутрь клиники. Меня волнует вопрос, как это выглядит в железе, то есть какие нужны вычислительные мощности, сколько серверов, насколько коек, насколько персональных компьютеров, ну, то есть рабочих мест врача, и какая сеть подразумевается под это все. Сколько потребуется администраторов для поддержания такой системы? Ну, видимо, тоже никто не ответит.
Ну, видимо, нужно, как просили передавать вопросы напрямую дальше профессору, видимо, так и тут.
Ну, просто это самое интересное, то, что вот такие штуки в докладах, они всегда интересны с какой точки зрения. То есть, если так делать сильную декомпозицию, то потенциально можно скинуть цену каждого компонента и просто что-то из этого сделать, наверное, какие-то финансовые оценки. Вот это не то, что моя тема, которая мне интересна, что я сразу побегу писать человеку, но просто хочется узнать, можно ли это сделать или нет с помощью этого подхода. Вот.
Это правильно. Всегда возникает сразу вопрос, а как это реализовать или что еще нужно?
Да, ну потому что конференция же инженерная, то есть всегда возникает вопрос по поводу этого. У меня вот к вам тоже вопрос. Вы занимаетесь, получается, импедансной томографией и вообще изменением импеданса, да?
Да.
Я видел, вот совсем недавно была работа тоже от вашей группы, вот на этой секции. Я ее слушал буквально несколько часов назад про руку, про управление, да?
Да.
Вот мне интересно, ну вот, насколько я понимаю, в России есть несколько компаний, у которых есть решение по импедансной томографии. И вообще тема же, она очень сильно исследована просто до невозможности. Там куча математиков, в том числе из МГУ, копалась в том, как это и томографией заниматься этим и прочим. Вот вы об этом что думаете?
По электроимпедансным вообще методам измерения, на самом деле их можно делить на 3 части. Вот то, что вы говорите про томографию, это только одна из больших 3 ветвей развития этих методик. Вот. По томографии, да, действительно у нас есть, но если говорить про аппаратуру, которая выпускается, импедансных томографов, ну, насколько я знаю, именно официально зарегистрированных, один компании Дрёгер. Все. Все остальное – это исследовательские какие-то машины, исследовательские системы, не более того. По математике, да, у нас есть, и действительно этим пытаются заниматься, но вот до продукта довести, конечно, это достаточно сложно. Да и у нас это вообще электроимпедансное немножко так это, ну, мало внимания уделяется этому направлению.
Ну, там потому что вот эти вот амплифайеры, которые параллельные, они же стоят безумных денег, они должны быть сильно экранированы, потому что кабеля параллельно находятся. Меряете малые токи. То есть, насколько я понимаю, основная цена именно в этом.
Ну, нет, не только. Но на самом деле в железке, чтобы померить вот, пульсовые составляющие, которые, ну, скажем так, очень качественно нужно и кабели, и электронику, и внутренние шумы надо очень хорошо с ними разбираться. Ну, сложностей действительно много.
Вот у меня еще вопрос по поводу этого. То есть, насколько я понимаю эту задачу в целом, она же все-таки используется на нескольких частотах, потому что у человеческого тела нелинейная зависимость от частоты этого. Есть даже обзоры, которые показывают, какие элементы, в общем-то, белков проводят как раз высокочастотные и низкочастотные компоненты. Именно на этом делается очень большой контраст в структуре ткани и прочего. Ну, плюс еще там вот чем мне нравится электроимпеданс, конечно, в него очень легко засунуть практически любой имиджинг. То есть можно и КТ, и МРТ, и ПЭТ, и вообще все, что угодно засунуть.
То есть... В каком смысле засунуть вот именно визуализацию? Тут просто вопрос, вот тот же электроимпедансная томография, которая используется, да, у нее разрешающая способность на порядок ниже, чем у КТ и МРТ. Ну да и просто чисто физически невозможно сейчас сделать так, чтобы там разрешение было 1 миллиметр. Это не получится.
Это невозможно, вот. Да, но поэтому... мы же можем, например, сделать снимок грудной клетки КТ, отсегментировать его по легким, и потом очень большой точностью измерять, собственно, прогрессию на
правильно. Я согласен, но на самом деле вот в своих исследованиях мы не занимаемся томографией, мы занимаемся отдельными поверхностными исследованиями с использованием отдельных каналов. Мы в итоге, вот мои коллеги как раз и добиваются того, чтобы на основе данных с КТ один раз получили, там с КТ или с МРТ какие-то внутренние, ну, изображения внутренних структур, размеры, и используя эти данные, потом можно получать и в мониторном режиме, и просто перемещение локальное и стенок желудочков, и перемещение центра масс, который сейчас, ну, никак по-другому не получится посмотреть. Вот, то есть действительно там как исходную информацию, да, можно использовать, а дальше уже пересчитывать там и в своих моделях учитывать эти данные. Вот, кстати, вот вы начали с разных частот и вот применения там вот белковые там и так далее, то, что разные проводимости. Да, есть такая штука, но на самом деле не только в этом особенность вот этих вот поверхностных методов измерения, неинвазивных. Там факторов, влияющих на сигналы, огромное количество, и одними белками там не ограничишься. Это во-первых. Во-вторых, если брать разные частоты, то вот как раз есть 3, вот с чего я начал, 3 основных вектора развития электроимпедансных технологий. Это вот томография, второе это вот то, что мы занимаемся поверхностными методами измерения, и третье это импедансная спектрометрия. И вот как раз в импедансной спектрометрии, или, знаете, ну, эта тема немножко хоть как до масс дошла с помощью оценка индекса масс тела, там, который, точнее так, процентное содержание там, мышц, жиров, там, воды и так далее. Вот в спортивных очень распространенные такие штучки. Вот. Такая методика вот как раз и нацелена на том, что измерения на большом количестве разных частот преобладают, что есть ткань. И в частности в онкологии вот такой подход тоже используется для оценки, родинка хорошая или плохая. То есть вот такие тоже методы есть.
Я вот просто знаю, что я занимаюсь сам моделированием электрофизиологии миокарда, то есть меня вот эта тема интересует, поэтому я довольно неплохо знаю, что происходит с распространением электричества по телу. Насколько я знаю, в России первыми, наверное, были ИВМ-РАН, которые этим занимались. Они занимались моделированием еще что-то либо в 5-м году, либо в 6-м, вот какие-то вообще очень-очень давно, больше 15 лет назад. Вы не пытались с ними связываться? Может быть, они что-то могут вам предложить?
С ними, насколько я знаю, ну вот у меня лично прямых контактов не было, и вот так вот на слуху за последние года не было таких контактов. Может быть, там у моих коллег и было что-то, но лично я не контактировал.
У них просто конференция проходит по мат-методам в биологии и медицине. Ну, просто вот мы, допустим, наша группа участвует не каждый год, как бы, вот. Ну, то есть по ней довольно много информации. Я могу сейчас в личку, наверное, сейчас скинуть просто.
Да, будет здорово, спасибо.
А у вас конференции какие есть тоже? Вот вы же из Москвы, получается. В Москве много чего есть. Может быть, я к вам тоже приеду, посмотрю, что у вас есть. Интересно было бы узнать.
С радостью приезжайте, мы с радостью с вами встретимся, конечно. Но из конференций таких вот у нас наиболее такая распространенная была это российско-германская конференция. Она так активно поддерживалась, базировалась на хороших взаимоотношениях нашего университета ВТ и университета Ахена, РВТУ. Вот. Но только вот в этом году что-то должна была быть в Германии конференция, но, судя по всему, ее так и не будет. Вот. Но она ежегодно, она там больше 15 что ли, лет уже существует. Ну, это такая основная наша международная конференция, в которой мы активно участвуем.
Ну, я что могу еще сказать? Да, такая же проблема. У нас тоже отменили все иностранные конференции, то есть они были запланированы, у них там было и тоже что-то пройдет в онлайне, причем непонятно как. Что-то, к сожалению, отменили. Да, и вообще год, конечно, специфичный.
Да.
Вот я как председатель секции, для меня, конечно, сегодня был самый сложный день из вообще всех подобных мероприятий.
Константин, а можно я добавлю?
Да.
Вот относительно биоимпедансных методов, именно вот направления томографии, вот Артем упомянул драгер, и вы, по-моему, в конце коснулись, затронули тоже Институт радиоэлектроники Российской академии наук.
Нет, Институт вычислительной математики я затронул. А радиоэлектроники я не знаю оттуда никого, к сожалению.
Ну, вот смотрите.
Я знаю только Институт приборостроения в Петербурге. У меня там один контакт есть.
Известный академик Гуляев Юрий Васильевич. Они давно занимаются этой тематикой. У них даже уже серийное производство биоимпедансных маммографов, если вы видели такие вот.
Да, маммографы точно есть, это да.
Да, причем у них это производство, и, по-моему, где-то в Ярославле, по-моему, или в Ярославле, да, в Ярославле у них там давно налажено это устройство. Вот, поэтому они давно этими вопросами занимаются. Да, вот вторая школа – это МГТУ имени Баумана, но здесь действительно только сигналы и измерения вот, поверхностные. Вот. А вот что касается изображения, томографии, то в России вот больше, мне кажется, вот такая ведущая школа в этой области – это Институт радиоэлектроники Российской академии наук под руководством Гуляева и Черепинин, по-моему, профессор. Он, кстати, был также вот на второй конференции в том году был у вас в Екатеринбурге. Он читал пленарный доклад большой, привозил этот же прибор, вот, его показывал, демонстрировал прямо на это. Если посмотрите фотографии из архива, там увидите.
Что-то я, наверное, мы про разные конференции говорим, потому что я не могу вспомнить про маммограф.
Нет, именно вот USBEREIT, вот вторая конференция, вот вторая.
Вторая, да, второй я очень мало участия принимал.
В том году, она же проходила в конце апреля в том году.
Да, но в том году секции были маленькими, то есть я тогда пришел на свою секцию, а на остальные мне просто было не было времени идти.
Угу.
Вот. Но я не мог полностью. Здесь же сейчас вот запись есть, то есть запись позволяет нам потом посмотреть другие доклады. Мне уже написали мои студенты, что они не будут смотреть в онлайне, не будут смотреть постфактум. Видимо, здесь вот как раз какие-то новые интересные вещи появятся.
А насчет того еще, какие конференции в данной сфере, в данном области, у нас вот во Владимире создали каждые 2 года организуется такая интересная конференция, как физика и радиоэлектроника в медицине и экологии. Она в этом году будет в начале июля. Могу ссылку прислать. Не уверен, что еще идет прием, но можно попробовать. Вот. Кстати, там есть школа, молодежная школа научная. В основном она организуется совместно с МГТУ имени Баумана, но другая кафедра. Не вот кафедра Щукина, а кафедра Самородова. Там в основном биометрия, там биометрические системы, технологии, обработка изображений. Да, то есть изначально всегда, как его, покойный Спиридонов,
да.
Спиридонов, а вот так, мне удается участвовать в этой конференции. Почему я не могу вам послать?
А вы из Казахстана или?
Я?
Да.
Лично, родом я из Йемена, но учился здесь во Владимире и закончил.
Понятно. Я просто немножко уже перепутал, тут лиц-то нету, и по фамилиям очень сложно. Я просто запомнил, что здесь кто-то был из Казахстана, хотел спросить, что у них было.
Из Казахстана вот девушка последняя.
Да, последний доклад был. Вот. Интересно, конечно. Спасибо, я увидел, да, что вы прислали. Я тоже прислал, но в личку прислал. Я не буду рекламировать ничего, кроме наших, чтобы мне в этом ничего не сказали. Да, интересно, обязательно посмотрю. Вот. Вот еще такой вопрос. А в каком объеме вы используете в работе мат-моделирования и машинное обучение? Просто, насколько я знаю, вот эту вот штуку с рукой, да, ее же Microsoft еще очень давно сделал через классификатор. То есть они просто машин-лернингом это сделали без КТ-шной модели внутри.
Это, да, конечно, по миографии это основная методика, которая позволяет много чего разделять. У нас просто, естественно, без миографии тоже не обходится. У нас и миография, и электроимпедансные методы измерения. Но у нас за счет вот разных каналов измерения получается повысить точность и повысить возможность количество движений, которые, вот если говорить именно про биопротезы, которые, как бионические протезы, вот современные, за счет вот дополнительного канала появляется возможность там где-то сейчас одновременную ротацию и сжимание-разжимание, то есть сразу несколько типов движения определять просто по тому, что вот человек какие-то на культе небольшие движения начал делать, ну и, соответственно, он сразу бионический протез отрабатывает. Вот, то есть здесь на эту сторону, в эту сторону мы смотрели.
А я правильно понимаю,
да, это да.
Я правильно понимаю, что в России завод по производству биопротезов находится в Владивостоке, или я что-то путаю?
Не знаю про Владивосток, я знаю то, что биопротезы РКК «Энергии» и «Неум», и еще один производитель собирался делать. В итоге делали, в итоге до серийно выпускаемого изделия, я не уверен, то, что дошло, не дошло, по-моему, нет. То есть я не слышал, чтобы вот наши именно бионические протезы появились. Есть только вот эти вот стартаперские всякие темы, когда, опять же, на классификаторе с помощью миоканалов делают какие-то на 3D принтере более-менее качественные протезы, и дальше уже на основании вот этого пытаются создавать продукты и продавать. Вот. Но не знаю про их объемы, сколько они производят, сколько они продвигают, не знаю.
Ну, я думаю, что печать на 3D принтере, там сама фишка в печати, он уже достаточно хорошо прилегает, то есть он персонализированный получается.
Да, здесь персонализированный, и дальше встает вопрос в элементе управления, да, это есть, то есть с обратной связью.
Угу. Окей, интересно. Я правильно понимаю, что вы из Бауманки?
Да.
А чем еще занимается у вас вот в плане именно исследований? То есть я так понимаю, что у вас очень сильная приборная школа.
Ну, да, как бы без электроники у нас здесь далеко не уедешь, и это достаточно много работ проводится. Вот вы тоже чуть раньше говорили про моделирование, да, у нас сейчас там ансис, консоль и так далее очень активно используем для того, чтобы просчитать, понять, какие факторы влияют на различные измерения, там, и так далее, и так далее. Если говорить именно про направление, вот в нашей научной группе у нас как раз вот протезирование, у нас исследование сердца, всякое разное, то есть и вот мои методы по оценке фазовой структуры работы отделов сердца, и коллеги делают вот систему мониторинга для оценки локальных перемещений в стенах желудочков и оценки движения центра масс. Другое направление, которое у нас, это использование электроимпеданса для оценки состояния печени, чтобы понимать, в первую очередь, например, приживаемость печенки при пересадке. С помощью электроимпеданса можно прям, ну, скажем так, значительно раньше увидеть то, что появляются какие-то проблемы при пересадке, и, соответственно, предпринимать какие-то действия. Направлений есть тоже, которые я как-то более-менее пытаюсь хоть чуть-чуть, но развивать. Это реопульмонография, то есть оценка, зональная пульмонография, оценка вот состояния легких в ходе лечения в основном. То есть как улучшается состояние легких. Ну, скажем так, это параллельный вариант решения оценки состояния легких, как вот делает Дрёгер, только там томография, а здесь отдельные измерения. Ну, вот. Ну, что еще из такого? Ну правильно, вот система по ЭЭГ, в частности, и система интерфейс мозг-компьютер, тоже у нас один мой коллега развивает, продвигает. Ну, то есть вот еще одно направление – это система автоматической функции вен, сосудов с поиском, с непосредственно введением и поиском вены, например, в руке, чтобы система точно попадала в вену, чтобы не было там двойного прокалывания.
Угу. Это контроль через УЗИ, наверное, да, через какой-нибудь?
Нет, импеданс тоже. Мы,
импеданс.
Ну, УЗИ, понятное дело, мы используем во время исследований, там в какие-то моменты, это, понятное дело, проводим как сравнение и корректировку своих решений каких-то. Вот. Но основной метод оценки локализации вен – это и во время автоматизации. Электроимпеданс получается чуть более выгодный, чем УЗИ. Потому что УЗИ все-таки он должен быть непосредственно в месте самого сосуда, и колоть там, где УЗИ-датчик, это неудобно. Ну, вот. А здесь электроды, они в стороне находятся, остаются, и это позволяет упростить несколько процедур.
У нас, мне кажется, вот в России, если так послушать, в целом, по России много кто чем занимается, но мне кажется, у нас нет какой-то крупной компании, которого бы конечным бенефициаром стало именно этих исследований. То есть у нас...
Вот. Это вообще большая проблема. И на самом деле у меня достаточно много времени занимает именно как раз вот это. часть работы не исследование, а попытка понять и договориться с кем-то из производителей о том, что что-то выпускать или что-то развивать. Они очень неохотно идут на контакт, на развитие. Они варятся там, какие-то разработки делают, ты с ними начинаешь разговаривать, давайте что-то делать, они вроде как да-да-да, потом это все сходит на нет, и, ну, да, это сложный момент, сложный процесс, этого явно не хватает у нас.
Ну, тут еще момент, то, что в клинике, на самом деле, большинство методов, они не используются. То есть, если посмотреть по работам вообще как бы обзорным, чуть ли вообще не все, что есть, там запихнули в организм человека, просто реальных приложений под каждый метод, их не очень много получается. То есть, всегда есть какой-то пик, когда вот люди вот это что-то делают, там все улетают. Импеданс-томография сначала 80-х, потом в нулевых, там, когда компьютеры нормальные появились, чтобы ее считать быстро, тогда был всплеск, конечно, по публикациям. Потом был всплеск по обратной задаче электрофизиологии. Тоже была куча работ, когда первый стартап в США выстрелил с этим. Вот. И сейчас, видимо, будет с коронавирусом, будут как раз все вкладываться в исследования, связанные с быстрым тестированием на что угодно, потому что все поняли, что сейчас важно не просто пытаться лечить, делать вакцины, а быстро тестировать на любое заболевание, чтобы у тебя через, там, условно говоря, 2 недели встало производство любых тестов под любые заболевания, которые бы ты нашел. И здесь, конечно, это, мне кажется, сильно сейчас качнет лодку именно в сторону биохимии, потому что биохимия, она как бы, ну, мягко говоря, там где-то до 80-х она прям бурно развивалась, потом это все перешло в электронное устройство, особенно потому что компьютеры появились, нормальные появились микросхемы, нормальное стало качество записи, можно было перестать делать фильтр баттерворда в этом ВКГ, можно нормальные фильтры делать, какие угодно. Вот. И, конечно, был всплеск и за рубежом, и в России. Но вот в России у нас из-за 90-х мы его частично пропустили, вот, и не стали бенефициарами этого развития. Ну, сейчас я не знаю, что, мне кажется, снова будет биохимия, особенно все, что связано с ПЦРом, полимеразной цепной реакцией, оно, наверное, сейчас будет более в активную сторону. Но это мое видение ситуации.
Это вот, ну, буквально там по последний год это получилось так, что достаточно активно с одним из наших производителей ПЦР, как раз всяких систем наших диагностических, лабораторного оборудования, они действительно пытаются сейчас развиваться и вполне себе нормально живут, чуть-чуть не злать. Вот. А по поводу биохимии, да, это точно. И если там несколько лет назад, там лет 5 назад был бум у нас на генетические всякие мат-моделирование там и так далее, генетика, короче говоря, она взлетела и достаточно хорошо так взлетела, причем даже на мировом уровне. Вот. А вот теперь, да, биохимия дадут дорогу.
Ну, мат-моделирование и биоинформатика, то есть вот машинное обучение, моделирование вообще отдельная сильная тема, то есть она очень специфична, и я не могу сказать, что она сейчас, она в нулевых годах развивалась очень бурно, то есть если посмотреть по количеству мат-моделей различных устройств, а есть их общие сборники там в специальных форматах, пик приходится на 2000 год. Вот. Потом эта тема медленно угасала, потом в 2010-м разродилась снова, когда появились нормальные суперкомпьютеры везде, стали более-менее доступны. Появилась нормальный способ расчета почти всего. Сейчас эту волну снова пытаются развить в США через ФДА, то есть так называемая наука, как они называют, Regulatory science, то есть наука о том, как создавать доказательства, как убедить регулятора в том, что ты не сделал то, что устройство безопасно. И первое, что давайте делать, это моделирование. То есть если ваше моделирование проходит определенные тесты, они сейчас сделали стандарт в 2016, по-моему, сделали по клапанам сердца, например. Вот, то есть если у тебя клапан сердца проходит определенные методами обрабатывает, дает корректный результат, то ты можешь говорить, что он, в всяком случае, не сильно опасен, да? Вот. Но мат-моделирование в целом, я думаю, что следующее возрождение, поскольку я сам этим занимаюсь, связано будет с машин-лернингом, потому что сейчас в СИАМе, это вот ассоциация прикладных инженеров-математиков, они в своем проспекте написали, что сейчас наша цель, одна из, ну, у них там 5 вызовов перед машинным, перед мат-моделированием стоит, и одна из них — это автоматически делать модели. То есть можем ли мы по данным, то есть не аналитика садить, который выводит формулы, а сделать такой метод машинного обучения, который это делает. Ну, такой метод есть, это, например, регрессия на гауссовых процессах, но просто она очень узкая, то есть мало что ей можно сделать. Вот. Но мне кажется, сейчас будет какой-то поворот в сторону математики, но, собственно, мы тоже этим занимаемся. То есть будет сплав машин-лернинга с этим, но он очень теоретически сложный, и пока не сложно предсказать. А генетика, она вот уже сейчас показала, что ПЦР это король, потому что все тесты, которые быстро проходят, это ПЦРные тесты. И сейчас, наверное, будет большой, конечно, всплеск. То есть коронавирус, конечно, продвинет исследования, еще, наверное, лет 5 эта тема будет просто топовая.
Да, очень может быть. Очень похоже, по крайней мере, на это.
Вот. Коллеги, а кто-то еще пытался работать в индустрии? То есть какие взаимодействия есть? Здесь, наверное, уже нету никого в чате. То есть люди как бы присутствуют, но они как бы мертвые. То есть...
Как бы есть, но как бы нет.
Да, это как школьники. То есть школьникам...
Чуть мертвые, оскорбляете.
Простите, пожалуйста.
Мы еще живы, фиг им. Мы не умрем.
Скажите, пожалуйста, вот вы в Перми работаете, так?
Я нет, я в Москве тоже в МГТУ с Артемом там и так далее.
А, понятно. Вот я правильно понимаю, что вы клинический исследователь?
Нет, нет, мы все на экспериментах и теоретические.
То есть у вас основной способ исследования – это гистология?
Нет, у нас эксперименты с фотодинамической терапией, тепловизоры и расчетные всякие модели.
Ну, у вас экс-виво или инвиво?
На образцах, не на
образцах.
Людях. Нет, ну тепловизор, конечно, на людях. А там, например, фотодинамика, это, конечно, на образцах.
Вот вы как видите развитие области в своей сфере?
Вы знаете, я нахожусь в таком шоке, что сейчас делается с объявлением этого якобы вируса, что у меня такое ощущение, что я вообще зря живу. Вот и все.
Ну, ладно, я не знаю, но, по-моему, слишком... Извините, если как-то задел вас вопросом.
Нет, ну правда, вот я сегодня послушала эту конференцию, думаю, зачем мы все это делаем, никому это не надо.
Ну, никогда не знаешь, что выстрелит.
Нет, дело не в этом. Вообще вся наука как бы не нужна. Они сейчас спрут по одному, вот эта биометрия вся. И им главное сбор информации по всей этой биометрии, а больше ничего не надо. Поделят людей на рабов и нерабов, и все.
Нет, ну, конечно, потенциально такой вариант есть. Другой вопрос то, что сейчас это актуально, там через год будет актуально другое. Это также, знаете, как есть, как же она называется-то, кривая Гартнера, международное аналитическое агентство, которое показывает и пытается строить прогнозы, какие технологии сейчас актуальны, а будут актуальны там через 5-10 лет и так далее. Вот, и там они каждый год, у них как-то прогноз был один, через год этот прогноз меняется и так далее, и так далее. Поэтому тут можно прогнозировать что угодно, а никогда не знаешь, какая из технологий все-таки в итоге окажется нужна и воспринята хорошо большим количеством людей.
Артем, если мы все сидим дома, какая вообще наука, на чем? Ну, может быть, кто-то напишет диссертацию, если у него материал есть, или какие-то штуки посчитает. Но в таком стрессе ничего хорошего сделать невозможно. Никаких ни экспериментов, никакие связи с промышленностью. Где вы промышленность видали? Почему не работает промышленность? Потому что ее нету. На чем они будут делать вам эти запчасти? Ни на чем. Не на чем просто.
Ну, я не совсем с вами согласен, просто потому что я знаю и общался, и видел вживую предприятия, которые работают и действительно создают продукт, который и выглядит уже прилично, и качественный, и есть куда развиваться. Поэтому не все так плохо. И общаясь с тем же Минпромторгом, который пытается как-то сейчас взбодрить радиоэлектронную промышленность, пусть там, конечно, планы год назад у них были одни, по факту получается несколько иначе, но во всяком случае я вижу людей, которые заинтересованы в развитии технологий, в развитии наших предприятий, в развитии взаимодействия между нашими учеными, нашими какими-то исследовательскими центрами, дизайн-центрами различными и промышленностью. И вполне себе мысли там витают вполне себе правильные. Другой вопрос, то что сложно, да, это все. Придет время, наверное, что-то все-таки станет лучше и выстроится в хорошем, скажем так.
Ну да, особенно после того, как правительство остановило всю экономику, да.
Ну,
давайте лучше не будем в сторону коронавируса, а то у нас потом это канал на YouTube за это заблокирует, и будут проблемы.
Ой, там такой показывает, что это мы ерунду говорим просто.
Коллеги, значит, смотрите, еще у меня такой, вот по поводу этого Министерства торговли и прочее, они же, по сути, оплатили все эти, замену всех электрокардиографических устройств в скорах Москвы. Насколько я знаю, не полные, вот ЭКГшки, которые в скорах по Москве, Московской области стоят, они сделаны полностью из отечественных компонентов. Я прав, насколько я...
Не знаю, я в поликлинике была и на скорой ездила, ничего там не очень-то они отечественные, но то, что они все на переносные заменили, это точно. То есть стационарных практически нигде нет, даже в поликлиниках.
Окей. Ладно. Ну, я не знаю, как еще поддерживать темы для разговора. Вот. Я оставлю здесь включенным канал. И, значит, наверное, я запись отключаю, потому что уже больше 40 минут прошло. Всем огромное спасибо. Я рад, что вы поприсутствовали на сегодняшнем дне. Вот. Завтра приходите.
Приятно было увидеть хоть каких-то живых людей.
Да. У меня, я со студентами работаю, у меня живые люди каждый день по Zoom. Но не каждый день, но часто бывает.
Ну, не знаю, мы тоже со студентами работаем, но что-то где они, живые люди-то, они же там все, бог знает где, по всей стране.
Ладно, я, наверное, вас покину, я отключаю сейчас запись, отключаю стрим. Эта комната полностью останется, я не буду закрывать митинг. Если кому-то надо, конечно, можно продолжать общение, там с чатов скопировать информацию, пока они не закрылись. Вот.
Спасибо, до свидания.
Спасибо вам.
Спасибо большое.
До свидания.
Всего хорошего.
Спасибо.
Успехов.
Спасибо всем.